Hello, good evening, and good day, everybody, and welcome back to the Ask Abhijit show. This is episode 365. I hope you're all doing great. Today, we're going to discuss fun stuff. This channel has been very heavy on geopolitics for quite some time now, so let's change track for a bit. We'll discuss aliens and UFOs and UAPs and space travel and whatnot. That's what we will discuss today. You all have asked a bunch of questions about that. I've picked a bunch of questions, and over the next couple of hours, I'll take as many of those as possible, and we'll discuss all kinds of topics related to aliens and UFOs and UAPs and space travel and related things. And after that, if you have other questions, I can take those from the super chat as well. No problem with that. So before we begin, let me see who all is there on the live chat. I can see America wale Shri Bhuri Chacha, Cheen wale Shri Panda Chacha, Rus wale Shri Putin Chacha, Hindustan wale Shri Modi Chacha, Israel wale Shri Pandit Chacha. Fascinating. Rana Hapana Hail Narayan. Harshay Hail Lohitang Ike Mars. Okay. Real Vladimir Putin. Rohan Bidi, happy Saturday to you. Ashwini Sharma, Shubh Sandhya ji. Ashwini Sharma is here from Bihar. Iya Dhruv Shah is here from Nepal. Good to have you, sir. Thank you very much. Hail Lord Pashupatinath. Geopolitical Dubey is here from Indore. Good evening, sir. Always good to see you. It's Aeon. Hello. Pratardana, namaste, sir. Abhishek Shukla Live, Mythos 5 banned. Yes, Mythos 5 is banned. There we have it. AI is a geopolitical thing, isn't it? Right? Okay. Abhishek Shukla Live is here from Kanpur. Shikari. Shikari is here. All right. Mary Kane, good morning, ma'am. Good morning. Dev Pradhan is here from Meerut. Good to have you. And Dev Pradhan in 2011 saw a silver disc-shaped object hovering near his house. Well, you are one of the lucky ones, aren't you? You saw something. Okay, Hot Flame Edits is here. Samarth Pramanik, namaste sir. Ayush Singh, pranam sirji. Safed Booth, good to have you. Who else? Manhattan I6W. Somi is also here. Somi 0709. Animals for Laugh. Good evening, sir. Sanath MN625. Hello. Vishwendra Singh, aka Uncle. Okay. Hello, G. Priyanshi Sood. Good evening, ma'am. Om. Ritika. Good evening, ma'am. GK. Namaste, G. Bin Salman. Hello. Sumit here. 36. Good evening, sir. I Ankit. Radhe Radhe. I Ankit is here from England. Good to have you. I hope you're well too. Ritika is here. Thank you, ma'am. Thank you so much. Somi is here from Jaipur, of course. Chat DSP, namaste. Good to have you back. Good to see you back. You've been busy for the past couple of months. Oh, we're all busy from time to time, but good to have you back. Niket Singh is here from the mountains of Banff. All right. Good to have you, Niket Singh. Rahul Dunake is here. Good to see you. And we're going to take some of your questions today, sir. Bin Salman also. Vinay Joshi. Pray to Indradev. Yes. Healthy monsoon. Okay. McLevin is here. McLevin wants the old geostrategy music back. Maybe we can do that. It's been a recurring request to have that music back. We can bring that back for sure. Hot Flame Edits. Aviral Gandhi, Chat DSP, Nikita Lalsa. Right. AC/DC songs, yes, of course. AC/DC. Back in Black. Right? Back in Black. And so many more. Who else? Anup is here from Pune. This is Harsh Kapoor. Full support. Full support to you. And lots of other people. I won't be able to greet you all individually. Nutan Roshan, Nikhil Vakhode, Business, etc. And so many other people. Okay, so thank you so much for all being here. And let's take some questions now. I won't be able to greet you all individually. But greetings to all of you collectively. And let's get going with some questions. What questions do we have today? Let's see. Where are the questions? I'm sure. Okay, here we go. Okay, E.R. Dhruv Shah says, what's the strongest evidence that supports the possibility of extraterrestrial life? Right. So we're talking about evidence here, not logical arguments or other kinds of arguments, actual hard evidence. That's what we're talking about. So are all these reports of UFOs and whatnot, is that evidence? In my opinion, that's not evidence because it is not incontrovertible evidence, right? It's not replicable evidence. You have people who see things. I'm sure they are seeing things. I'm not saying that they're not seeing things. They're not imagining it because nowadays people take videos with their cell phone cameras and whatnot. And those videos typically aren't the best videos. They're kind of out of focus and all, because these are distant objects and whatever. But that is still not quite hard, incontrovertible evidence of the existence of aliens. That could be classified secretive technology. Those could be military, you know, objects or military aircraft that look like UFOs, right? Secret military aircraft. It could be any of that. So you can explain that without requiring the presence of aliens on Earth. You can explain. There are logical, plausible reasons that don't require the necessity, that don't necessitate the presence of aliens on the planet. So these UFO, UAP videos, etc., they don't constitute evidence in my book. Even what the US government is releasing and so on, it doesn't constitute actual hard evidence. What's actual hard evidence? An actual UFO that's present and journalists can go and see. Our Indian 8 p.m., 9 p.m. journalists can see it, send a delegation there and photograph it or take a video, right? And it can, if you can make it hover, that's evidence. And even that could be secret technology, even if that is demonstrated. But the presence of maybe a captured alien or maybe the body of an alien, that's hard evidence. We don't have any of that. So what's the actual strongest evidence? There's argumentative or logical evidence that there are 10 raised to 23 stars in the known universe. Assuming each star has one planet, what's the chances of life? And that sort of thing you can do. But that's logic, that's statistics, that's not actual evidence, right? That maybe if 1 in a million stars have life, and maybe 1 in a million, places where you have life, you may have intelligent life, and that sort of thing you can do. But even that's not evidence; it's just arguments. So, what's the actual evidence that we have? Do we have evidence? Well, we have some pieces of tentative evidence that could potentially demonstrate or hint at the evidence of extraterrestrial life. So what is that? So first of all, there is something that was once detected a long time ago. It was never detected again. I think it was in the 1970s. It was called the wow signal. Wow signal. There is that. Then there is the detection of certain kinds of gases on other planets that on Earth at least are the telltale signature of life. Phosphine gas. It's produced by anaerobic bacteria on our planet. Bacteria that don't use oxygen for their biological functions. Anaerobic bacteria. So these bacteria, they produce phosphine gas, which is a toxic gas for us. It's lethally toxic, essentially. But these bacteria, they produce it in small, tiny quantities. And if you find that somewhere, it's typically, regarded as the evidence of at least some kind of microbial life. So let's go back to the wow signal. What was this wow signal? Let's Google that. Wow signal. Which telescope discovered it? Wow signal. So there was 1977, Ohio State University's Big Ear Radio Telescope. Okay. So it was so unusual and strange that the scientist, the astronomer who saw this in the printout, he wrote wow next to it. So what did it look like? That's what it looks like. It's just astonishingly unusual. Okay. And it came from the direction of a certain star system or certain direction. And it's never come again. Right? Where was this? Which part of the galaxy was it from? It doesn't say it here. So that number that you see, 6EQUJ5, it's an alphanumeric number. Okay. And it was recorded at a frequency that's naturally emitted by neutral hydrogen and so on. So this still can't be explained. As far as I know, it still can't be explained. So this is one evidence that's potential evidence of potential extraterrestrial life, potentially. What's the second one? It's phosphine gas, right? Okay. Phosphine gas Venus. Okay, yeah. So Venus is our neighboring planet. Okay. And phosphine gas was discovered on that planet, on our neighboring planet, in the atmosphere of Venus in 2020. And that gas, there's no natural explanation for that. But on Earth, it's produced by anaerobic bacteria. So that could potentially perhaps be the sign of, who knows, maybe some kind of life, microbial life on Venus potentially, right? But it's controversial and so on. So these are two pieces of evidence that we have that could potentially indicate life. The wow signal could potentially indicate, if it's artificial, it's not something that was created or emitted by bacteria. You need intelligent life for that. Okay, so the wow signal could be the sign, or the signal, a signal that came from an intelligent civilization. And the phosphine gas on Venus, well, that could be bacteria or microbial life forms. So that's what I can think of. Do we have any other evidence? Not that I'm aware of. Okay, so yeah, and of course we have the presence of various icy bodies in our solar system that do harbor subsurface oceans of liquid water. Europa, Enceladus, and Pluto, and so on. Pluto also most likely. And if these subsurface oceans are liquid water, then there could perhaps potentially be at least microbial life there. But we don't have any evidence thus far. So these are the various pieces of evidence that we have. But there's nothing conclusive. Nothing that's 100% conclusive. So that's where we are. Okay, Nanesh and Napoleon Singh Shekhawat says, Nanesh says, why are aliens always projected as bipedal and identical or similar to Homo sapiens? Why can't they have wings? Or why can't they be made of inorganic compounds, right? And Napoleon Singh Shekhawat says, when and how did this popular depiction of aliens with this round, oval face, gray skin, big black eyes, when did this depiction, when was it first shown? When was it all the imagination of somebody, of a person? Or did the person, whoever created this, did they actually meet an alien like this and ask for a sketch? Okay. So first of all, why are aliens depicted as humanoid in form? Humanoid, right? 2 arms, 2 legs, hands with maybe 5 or 4 or 3 fingers, but fingers, and a head, humanoid head, maybe big eyes or whatever, nose, mouth, maybe no nose, but definitely a mouth. So aliens are typically depicted like that, right? Why is that so? Why aren't aliens different in popular depictions? Why don't they have wings, like you say, or a tail? Or why aren't they made of inorganic compounds? Right? So how did this all come up? So I think this all appeared in popular imagination because of various movies and TV series and whatnot. And if you make in popular depictions, whether it's a TV series or a movie or whatever, if you create an alien that's absolutely unrecognizable as a life form, then people won't be able to relate to it or see it as an alien. So an alien has to look kind of human, but different. It has to look uncanny valley. That's how you will evoke the right emotions in the audience. Fear, being creeped out, that sort of thing, right? Because aliens typically are invaders or whatever in movies, right? Alien invasions and so on. So that's how this entire depiction began. Nobody has ever seen an actual alien, as far as we know. There's no evidence of it, no hard evidence, right? So when was this first shown? I suppose it must have been first shown in the 20th century at some point in time. H.G. Wells' The War of the Worlds must be 1920s, 1930s, around that time, right? It started as a radio show, and that set off panic in some parts of the United States because it sounded so realistic, right? So I think it's in the 20th century that these depictions became popular. And these are all creative depictions, typically done by artists. So what do actual aliens look like? If they exist, we have no idea, right? But typically you want them to look humanoid if you want to elicit the right kind of reaction of fear and all that from the audience. So that's why they're depicted like that. So they're depicted as humanoids, but not quite human, right? 2 arms, 2 legs, 3, 4, 5, whatever fingers, big eyes, bug-like eyes, small mouth. Some of them are 8 feet tall, some of them are 3 feet tall. Even E.T., Steven Spielberg's movie, that has a humanoid alien. It's got a kind of humanoid shape and size and all that. So that's how it is. That's why it's so. Have aliens ever been depicted as having wings? I think what's that military sci-fi novel where there are insectoid aliens? So you have some of these sci-fi novels and TVs, Starship Troopers. So you have insectoid aliens in that. They have wings, some of them. Yeah. What about inorganic compounds? So yeah, we think of aliens as typically being made of carbon compounds because we are a carbon-based life form. But why can't you have silicon-based life forms? That's also potentially plausible. Why can't you, instead of having water-based life forms, why can't you have methane-based life forms? Anything is possible. I'm sure there's all kinds of potential biological possibilities out there. But that's too alien for us. We want them to kind of similar to us, and that's why it's depicted like that. Yeah, so I don't think anybody actually met an alien who looked like that and asked for a sketch or a photograph or an autograph or a vlog. Yeah, it's just imagination. Napoleon Singh Shekhawat says, why don't aliens visit Earth? Shouldn't it be possible that the aliens who are advanced, more advanced than us, they don't visit us because they live light years away from us? And those aliens that are close enough to us might still be living in a stone age of their planet. Or maybe they visited some other planet that looked like Earth or Uarth and confused it to be Earth. What's the deal? So why don't aliens visit the planet, visit our planet? That's the question you're asking. And what are the different plausible or possible explanations for that? Well, one possible explanation for that is that maybe we are entirely alone in the universe. There's only humans, there's only life on Earth, there's nothing anywhere else. So that's, nothing anywhere else in the sense that there's no other intelligent life forms out there anywhere else in the galaxy or maybe the universe. Maybe in the entire universe, we are the only intelligent species that exists. That's a rather terrifying thought, if you think about it. So that's one possible explanation, that there's no other intelligent life out there. Maybe there's life, but that's mindless, stupid life. Maybe it's like butterflies and insects, or maybe it's just microorganisms, or maybe jellyfish or whatever, but nothing evolved, nothing intelligent, nothing that can create its own technology, nothing that has language, nothing that can think of venturing beyond its home planet. Maybe there's nothing like that. So that's one explanation. That's why aliens never visited, because they simply aren't intelligent, or maybe they don't exist at all. The other explanation is that it's because space is so vast. Just reaching the moon for us is such a challenge. Reaching Mars, we have never reached Mars. We've never sent humans to Mars. The furthest that any of our spacecraft has reached away from Earth is approximately 1 light day. Right? Voyager 2. It's slightly more than 1 light day away from the Earth. So if you send a light signal to Voyager 2, it's going to take it slightly more than 24 hours to reach there. So that's a pretty big distance, actually. But in the bigger scheme of things, it's insignificant. A light day, that's nothing. The nearest star, the Proxima Centauri system, that's about 4.1 light years away from Earth. Right? The space is so vast. Even our local neighborhood, in terms of the closest 20 or 30 stars, they're incredibly far away in terms of light years from us. And we can't even begin to imagine how we would cross those distances right now, given the kind of technology we currently have. So maybe the space is so empty and so vast that even if aliens, may perhaps be aware of our existence, they may not have the technology to reach here, right? Because if you use chemical rockets, it's going to take us tens of thousands of years to travel such distances, and we don't have anything apart from chemical rockets. You can use nuclear propulsion and other things, but it's still conceptual. It's not actually feasible currently. So that's why maybe the distances are too vast. That's why, perhaps. And the third possible explanation is that we are just insignificant and no one cares about us, even if they are aware of us. Maybe there exist alien civilizations that are so advanced that to them we may look like bacteria, as evolved as bacteria. They may be observing us right now and we may not even be aware of it. For example, if you take a petri dish, put bacteria in it, and then you put that under a microscope, and you look into the microscope and you observe the bacteria, you can see them teeming around and replicating and whatnot, cell division, meiosis, mitosis, etc. You can see them do all that. But those bacteria, they are blissfully unaware of the fact that they are being observed by us. They don't even know they are being observed. So maybe there are civilizations or alien life forms that are so advanced that compared to them, we are like bacteria. And maybe they are observing us right now, and we are not even aware of it. It's also a possibility. So there's multiple possibilities. The simplest explanation is that either space is just too vast and nobody is advanced enough, or we are alone, or we are simply so insignificant that the alien civilizations don't care about us. And they're so advanced that we simply can't detect them. These are some of the possibilities. And there's other possibilities to the great filters and all, which we can discuss further on. Real Vladimir Putin says, what are the key conditions necessary for life on a planet? And what amount of time is generally required for the evolution of life on a planet to produce intelligent species like humans? Okay. So if you ask me what are the conditions, the key conditions necessary for life on a planet, well, I can only tell you based on the data that I have. I can only answer the question only on the basis of the data that is available to us. And the data that's available to us is the data from planet Earth. That's the only place where we know life exists. So based on that, I can tell you what are the key conditions necessary for life on a planet like Earth, right? So what are the conditions needed? You need the right chemical composition of the atmosphere, of the oceans. You need large quantities of water, liquid water. If it's too hot, then the water just boils and evaporates and there can be no life. If it's too cold, then the water just freezes and there can't be life. So you need liquid water. Then you need the right kind of atmosphere. And the right kind of atmosphere for some kinds of life will be terrible for other kinds of life. For example, the early Earth, about 4.5 billion years ago, it was a toxic hellhole. The atmosphere was noxious. It was toxic. Carbon dioxide and God knows what other gases, sulfur dioxide, all kinds of horrible, noxious gases existed in our atmosphere. If you had that atmosphere today, it would mean the end of all life forms immediately. Right? So that's the kind of atmosphere we had initially. And the planet was a hellhole. First of all, the day was not 24 hours long, it was about 10 hours long. The Earth's rotation speed was very fast, and the whole planet was molten. Initially, molten. Then the surface started cooling, but you still had tremendous amounts of volcanism. You had very heavy bombardment by asteroids. You had the collision with an ancient protoplanet called Theia, which gave rise potentially to the moon, possibly. And then you had this heavy bombardment of asteroids and comets, which probably seeded our planet with water. And then you had the right conditions for life. So the earliest unambiguous evidence of life on our planet is from about 3.77 billion years ago. That's stromatolites, microorganisms that created those structures that we call stromatolites today. And then you had cyanobacteria that created the great oxygenation catastrophe. a very large quantity of cyanobacteria colonized our planet, and they produced so much oxygen that the entire atmosphere of the planet changed, and the oxygen poisoned almost all life, because for that life, for those kinds of life, oxygen was a poison. Even for us today, too much oxygen is poisonous. Okay, oxygen is about 20 or 21% of the composition of our atmosphere. So based on the only data that we have, those are the conditions for life. Okay, so your planet has to be in the habitable zone around the star, around its parent star. What is the habitable zone around a star? It is the zone that's neither too close to the star nor too far away from the star. It should be in the exact right position where you can have liquid water on the planet. That's called the habitable zone, or the Goldilocks zone. Neither too hot nor too cold. Okay, so that's typically considered to be the habitable zone. And it is said that if a planet is in that zone, then there's a higher possibility of life. But we are considering life that is water based and carbon based. You could have other kinds of life that could thrive in very different environments. You could have life that could thrive potentially on Saturn's moon Titan, which doesn't have water, which has flowing hydrocarbons and methane and whatnot, very thick atmosphere, but very different from Earth. So that also potentially could have life. But we have never encountered such life. So based on the only data that we have, the key conditions are that your planet has to be in the habitable zone, where it's neither too hot nor too cold, so that liquid water can exist, and then potentially you can have life. And you also need to have an atmosphere that is breathable and all, which means oxygen. So you need oxygen, you need water, and flowing water. That's typically what we regard as the key conditions necessary for life on a planet. What amount of time is required for the evolution of life? So our planet is 4.5 billion years old, and life evolved 3.77 billion years ago. So that's how much? 730 million years it took for life to evolve on our planet. But how did it evolve? How did it acquire DNA? Those questions we still can't answer. And after the first emergence of life on the planet, it took essentially almost forever for intelligent species, one intelligent species, to emerge. That's us, right? So Homo sapiens is 400,000 years old, less than 500,000 years old. So it essentially took 4.5 billion years for intelligent life to emerge on our planet. So that's the only data that we have. We don't have data from 78 other planets so that we can take an average. We don't have any such thing. So that's all we can say. Of course, we can speculate about all kinds of things, but that speculation is it's not grounded in data, so it is not really valuable. Okay. Somi says, could humans colonize moons like Titan, Europa, Enceladus, or Ganymede? Could they have microbial life already? And Rahul Dunake says, which of the two moons, namely Europa and Enceladus, have a greater chance to harbor life? Why doesn't NASA carry out a robotic expedition to these two moons instead of to Mars? Okay, interesting question. So we have these. So the moons that you're referring to are the moons of Jupiter and Saturn. Titan is a moon of Saturn, the largest moon in our solar system. It's got a thick atmosphere, an atmosphere that's rich in hydrocarbons. It's very different from our atmosphere. It's a very, very cold world. You have liquid methane, you have lakes and rivers of liquid methane. And there's a rain of hydrocarbons, there's snow of hydrocarbons on Titan. So that's a very different world. Then you have Europa, you have Enceladus, you have Ganymede. These are worlds with subsurface oceans. So Europa is what? Jupiter, Saturn? I think it's Saturn. Let me just double check. Okay. Europa is Jupiter's moon. It's Jupiter's icy moon. Europa. Then you have Enceladus. Enceladus is Saturn, of course. Ganymede must be Jupiter. Ganymede it's Jupiter, right? So these are all different worlds. Titan is not a water world. Titan is a hydrocarbon world. Europa, Enceladus, and Ganymede all have subsurface oceans. Okay, so which is the moon that has geysers? Probably Enceladus. Probably Enceladus. Yeah. So these are all interesting places with subsurface oceans. So you have a crust that's made of ice. You have kind of tectonic activity that creates cracks in the ice, and because there are cracks in the ice, that you can infer the presence of a liquid reservoir under the ice. So since these moons are so far away from the sun, why aren't they completely frozen? If there is water, why isn't it just completely ice? Why is there a subsurface ocean on these planets? And there are different reasons for that. So these are on these moons, not planets. So these moons, they come under the effect of the tidal forces of their of the planet Jupiter or Saturn. And the tidal forces cause internal heat. They create internal heat inside, which causes the subsurface region to become liquid, to remain liquid. So there is enough heat for the water to be liquid. And if there's liquid water, there could be microorganisms there. Now you will definitely ask that microorganisms, how will they survive without sunlight? On our planet, nothing survives without sunlight, right? Every organism needs sunlight to survive. For example, you have plants. Plants need sunlight to perform photosynthesis, without which they die. And herbivorous animals eat those plants, and carnivorous animals eat the herbivorous animals. So if the plants die without sunlight, then the herbivores will die, and therefore the carnivores will die. And even the insects and everybody else depends on plants eventually. So if there's no sunlight, there can be no life on Earth, or can there be? There actually can be life on Earth without sunlight, certain specific types of life. For example, on our planet, we have something called hydrothermal vents. Okay? Hydrothermal vents, worms. So there are certain kinds of worms that live deep under the water where there is no sunlight or almost no sunlight, and they thrive in these places called hydrothermal vents, which are essentially subsurface volcanic openings, essentially. So very hot vents of water which raise the temperature of water to above probably 100 degrees Celsius, and that's where these strange organisms live. And they are able to survive because of the temperatures and the chemistry of these hydrothermal vents. So they don't need sunlight. They rely on the heat and the chemistry of these oases in the ocean, at the bottom of the ocean. So you can have life without sunlight. So if you have, let's say, Europa or Ganymede or Enceladus, where you have subsurface oceans which are completely covered by a several kilometer thick crust of ice, then clearly there's no sunlight down there. But there is some source of heat, and that could potentially, be able to harbor life. But we don't have evidence of that thus far, because we have never sent an expedition there. So microbial life could exist there, maybe even slightly more complex life than microbial life. You don't know. We don't know about that. So which of the moons has a greater chance of life? I think they all probably have similar chances of life. Why hasn't NASA carried out a robotic expedition to these moons instead of Mars? Well, that's the question of money, capital, finance. These expeditions are really expensive, right? So if you want to send a payload of, let's say, 1 kilogram to Earth orbit, how much does it cost? Let's see. How much does SpaceX charge to lift 1 kilogram payload into Earth's orbit? Typically, $2,200 to $7,000 per kilogram. Okay, that's just Earth orbit, low Earth orbit, 200 kilometers above the surface of our planet. 150, 200, 500, whatever. Okay. Um, so yeah, let's say it's $5,000 per kilogram. That's just low Earth orbit. But if you want to send a kilogram all the way to Jupiter or Saturn, it's gonna cost millions or maybe tens of millions of dollars. Probably hundreds of billions of dollars. So typically a mission like this will cost around $1 billion or more. Okay. Let's figure out, okay, how much did the Cassini mission cost? How much did NASA's Cassini mission cost? Let's see. $3.9 billion. Okay. And that did not involve a soft landing on a moon of Saturn and then penetrating below the surface, the tremendously thick crust of the moon, and diving into the ocean and then taking samples and then relaying it back to Earth. That's very complicated. It could cost tens, maybe, yeah, definitely tens of billions of dollars. And it's very complicated. The chances of success are low because it's so complicated. So that's why it's not been done so far. What you could do is you could send a small submarine. You could send a spacecraft that will enter the moon's orbit, and then it will lower a submarine onto the surface of the moon. And this submarine, let's say it has a nuclear reactor that produces heat, which will start melting the crust, and in a few weeks or something, it'll go all the way to the bottom of the crust and dive into the ocean. Okay, so then it can collect samples and figure out what's happening under the surface in the ocean itself. But then there's the question of how does it send back that information to the planet, to Earth, back home. So it's pretty complex, and that's why it's not been done yet. I'm sure there are conceptual plans for this, but right now nothing solid, right? Because it's so complex. So that's the reason why. Sending missions to Mars is way simpler. Even that's super complex, but that's way simpler than doing what you're proposing. So yeah, it will happen eventually, but it's going to take a lot of money and a lot of high-end engineering. Somi says, what's causing Tabby's star? So there's this astronomer, this lady, whose name is Tabetha Boyajian, who discovered a star, the Where's the Flux star, WTF star. Okay. So what's the deal with this star? Why is it called the WTF star? Where's the flux? So this star exhibits really strange properties. Okay. So first of all, how do you look for exoplanets? What's an exoplanet? An exoplanet is a planet in orbit around another star, not our star, the sun, but another star somewhere else. So one of the ways of looking for exoplanets is to measure the intensity of light that's coming from a star. And let's say there is a 0.1% dip in the intensity, then that potentially indicates that a planet crossed, the line of sight between us and the star. And then we wait. If that happens periodically, let's say once in 78 days or once in 400 days, and it happens regularly, then you know that there's a planet orbiting the star, and it's causing a small but measurable dip in the intensity of light coming from the star. Okay, maybe 1% if it's a hot Jupiter or something. If it's that sort of thing. So that's one of the ways of detecting exoplanets, by measuring periodic dips in the intensity of light coming from a star. So now this lady, Tabetha Boyajian, she discovers this star and measures the intensity of the light coming from there. And there are dips, small dips, medium dips, significant dips, but the dips aren't periodic. It's dimming and brightening irregularly. There is no periodicity to it. And this was measured for quite some time, and there's no pattern to it. What is that? Why is there no pattern to the way the dips are happening? dips in intensity of light. So one explanation that was proposed was that somebody is building a mega structure around the star, a Dyson sphere or Dyson swarm. What's a Dyson sphere? What's a Dyson swarm? A Dyson sphere is a conceptual piece of mega engineering where you create a structure around a star to capture all of its light and heat. And then you use that light and heat as energy to power a massive hypercomputer or something, or do whatever you want with it. So only an extremely technologically advanced species can do that. There is nothing in the laws of physics that says it can't be done. So what's a Dyson sphere and swarm look like? Let's take a look at that. Okay. Dyson sphere. What does a Dyson sphere look like? So this sort of thing, you see, Dyson sphere. You essentially encompass the star in this massive structure to capture all of its light and all of its energy, and then you harness that energy to do whatever you want, maybe run a hypercomputer, supercomputer, and so on and so forth. So that's a Dyson sphere or a Dyson swarm. You can have a cluster of such receptacles that harvest the energy of the star. So if some alien civilization was creating that sort of structure, then it could potentially lead to these weird dips in the brightness of this star. Okay, so that's why this star became very famous. Let's quickly Google it up. Tabby's star, WTF star, right? Boyajian's star. So it's about 1470 light years away. Okay, the dimming events were unpredictable. They blocked up to 22% of its light. That is massive. That's massive. 22% of its light getting dimmed. It means there's something massive between you and the star, right? Essentially, it's covering more than 1/5 of the star's surface, or it's occluding more than 1/5 of the star's surface. And this was completely, unpredictable. There was no pattern to it, and that's why it became a huge mystery. And that became, there was significant and very strong speculation that there could be some aliens at work there. And then the question was, can we explain this using natural explanations, natural causes? And potentially, I think you can have natural causes that can cause this. Maybe a huge swarm of comets around the star. And comets, they can come and go, whatever. So that's why the pattern isn't there. There's no actual timing. So maybe a swarm of comets can explain this. Let's see what the AI has to say over here. Leading explanations: comet swarms or planetary debris, the most widely accepted scientific theory. Then interstellar dust, and then alien megastructures, right? That sort of thing. So the most widely accepted theory is that the star is surrounded by a massive uneven cloud of dust, swarm of comets, or the debris of a disintegrated exomoon or exoplanet. So we try and explain this with natural explanations. Now, can a cloud of dust explain 22% dimming? It's a little bit of a stretch. Can a disintegrated exoplanet explain 22% dimming? It's a bit of a stretch. Can a swarm of comets explain 22% dimming? It's once again a bit of a stretch. But that is the leading explanation. We don't want to go all Deus ex machina and say this aliens. So we try our best for, a plausible, tame explanation. So I think, in my opinion, it's still a mystery. I'm not very convinced with the explanation that a disintegrated or destroyed planet is occluding 22% of the star. It's a bit of a stretch. And comets also, how many comets can a star have? How can they occlude so much of the star's light? A cloud of dust could possibly explain that. Possibly. Yeah, but it's still not that convincing. So I think it's still a mystery, but the excitement has died down now. It's been more than a decade now. So that's the mystery of Tabby's star. Somi says, can you explain what these great filters are? What are these great filters? So the great filters, to understand that, we have to first understand the question that Enrico Fermi asked all those decades ago, probably in the 1950s or 60s. Enrico Fermi was one of the great physicists of the 20th century. And he was unique as a physicist because he was equally at home in theoretical physics and experimental physics. He was both. He was an all-rounder. He was a theoretician, a brilliant theoretician, and also a brilliant experimental physicist. Typically, these two disciplines don't mix. Experimental physicists will stick to experimentation, devising new experimental devices and constructing them, and then using them to test theories. That's experimental physics. And theoreticians are going to work with pen and paper. They don't want to get their hands dirty with engineering and all that. But Fermi was both a brilliant experimentation and a brilliant theoretician. So Enrico Fermi asked this question. The question he asked was very simple. Where is everyone? Now, what do we mean by that? See, we know roughly how many galaxies we have in the universe. And we know roughly, on average, how many stars does a galaxy have. So if we add up the numbers or multiply the numbers, we get a total of about 10 raised to 22 or 23 stars in the observable universe. That's one with 23 zeros after it. That's a mind-bogglingly unimaginable number of stars. 10 raised to 23 stars in the observable universe. So if there's so many stars, and let's assume each star has at least one planet. So there's 10 raised to 23 planets in the observable universe. Let's say there's a 1 in a million chance of a planet having life. So divide 10 raised to 23 by 10 raised to 6. You get 10 raised to 17. So there should be 10 raised to 17 planets which harbor some form of life, maybe microbial life. Maybe there's a 1 in a million chance that a planet that has life develops intelligent life like us. So you divide 10 raised to 17 by 10 raised to 6, you get 10 raised to 11. So there are 10 raised to 11. That's 100 billion planets, plausibly, in the observable universe where there is intelligent life, similar to ours at least. So if there's so much life that should be out there, where is everybody? That's the question. Why haven't we heard from them? Where are they? Where are all the aliens? That is the Fermi paradox. And we don't have an answer so far. Where's everyone? We don't know, right? So how do you explain this? The absence of any aliens who have knocked on our door. Well, one possible explanation is that we haven't been around for that long. Okay? 150 years ago, we thought that the Milky Way is the entire universe. 200 years ago, we did not know there was a Milky Way. Right? 300 years ago, the Europeans thought that the world is flat. And so on and so forth. So it's only very recently that we have realized what the universe is. And it's only very recently that we have developed the technologies needed to receive signals from beyond our star system. In the past 100 years only. 100 years, it's like a blink of an eye in cosmological terms. Nothing. It's nothing. 100 years. So maybe we haven't had time to receive signals. We've been around for so small a period of time that we haven't received anything. Maybe we should be patient and we'll find something. That's one explanation. The other explanation is slightly scarier. The other explanation is that there are great filters that prevent civilizations from acquiring the technology to travel interstellar distances. So, what are these filters? Filters are catastrophes that can happen to life forms or to a species. For example, let's say a planet develops unicellular life. Now, if you have unicellular life, making the jump from unicellular to multicellular life, it's a big jump. Maybe in most planets, it never happens, perhaps. So that's a big, great filter. Maybe for some reason, life never makes the jump from unicellular to multicellular life. That's one possible explanation. That's one filter. Second filter, maybe the conditions on the host planet are such that intelligent life can never develop. Maybe it's a water world. There's no land. It's only water. So these species can only, even if they are multicellular, they can only be fish-like or whale-like or dolphin-like species, but they can never emerge beyond the ocean. That's a second filter. But let's say there is land and the species eventually crawl out of the oceans and become land-based species, and they look up and they can see the stars and they can start wondering about that, and eventually they become intelligent. So let's say intelligent life does develop, but maybe they are, for whatever reason, they are never able to develop technology. Like for example, us Homo sapiens, we have been around for 400,000 years. It's only in the last 200 years that we developed modern technology. Actually, last 26 years. The quantum was discovered 126 years ago only. Until then, we were like really primitive, weren't we? So maybe even if species are intelligent and they are land-based, they never develop technology for whatever reason. That's another filter. One more filter, maybe they develop technology, but then they use the technology to destroy themselves. Maybe they develop nuclear technology and then use it for the wrong reasons and for the wrong purpose. Maybe they use it destructively. Maybe they develop nuclear weapons and create an arms race and then they kill each other off. So maybe even if on some planets species become intelligent enough to develop highly evolved advanced technology, maybe they end up using the technology to kill themselves off. That's another filter. And similarly, there are multiple filters, and maybe we have transcended 2 or 3 filters, but we may be now looking at the last filter, which is the nuclear filter. And right now we have a situation on our planet where one mistake could destroy the whole planet. So maybe that's happened to other species in the past. So these are the great filters. And these filters can plausibly, potentially explain why nobody has contacted us. Because maybe these civilizations just end up killing themselves. These filters kill them off. Right? So that's the great filters. And that's a plausible explanation of the Fermi paradox. Okay, Sobi says, what exactly do the UAP files tell? From what I know, they don't prove that aliens exist. So the US government, under the visionary leadership of Shri Donald Trump G, has decided to release the UAP files. And I think yesterday or today, I think the 3rd installment of the files was released. So when the first installment was released, I went through a few of those. I did not go to the website and dig out all the things, but I took a look at whatever people were posting on social media, video clips and all that. And if you see these video clips, they prove nothing. They prove nothing whatsoever. There's no conclusive evidence of flying saucers or UFOs or UAPs. It's blurry stuff that's happening. Looks intriguing, but you can't tell if it's real, if it's AI generated. You certainly don't see any aliens in there, right? You don't see any alien life forms in there. Nothing conclusive, nothing unambiguous. And they have provided no proof that they have any contact or communication with aliens. So it's just releasing videos, and now they're releasing some transcripts and some recordings of conversations, maybe conversations between Houston and the astronauts, wherever they were, of the astronauts seeing something strange and they can't explain it. But once again, there's no conclusive evidence of anything. Maybe this was something strange that they could not explain. But what exactly was it? Are these recordings authentic? Are they fabricated? You can't tell. So from what I have seen, it's a non-event. It proves nothing. It discloses nothing real, nothing significant, nothing valuable. It doesn't put any mystery to rest. It doesn't really disclose anything secret. So what do the UAP files tell? They tell you nothing. Nothing significant or valuable, as far as I can see. Maybe I can get some UAP researcher or somebody who could perhaps throw better light on this. Maybe I can do that. But as far as I have seen nothing significant in any of what's been released. Yeah, so it's overall been a disappointment, unfortunately. Okay. JDN says the UFO and alien narratives are all massive BS cooked up at Area 51 over the last 60 years. Believe in it and you will be chasing it for the rest of your life. So what is this Area 51 is the question. Right? Area 51 is this place that's somewhere in the US that is believed to be where the US government is hiding UFOs and aliens. That's what one hears. And maybe they're testing secret technologies. Maybe they're reverse engineering captured alien spacecraft, or the technology from captured alien spacecraft, or recovered alien spacecraft. And maybe they've stored the bodies of aliens who crashed in a UFO there. And maybe they did experimentation on those bodies. That's the kind of stories one hears. And it's not allowed for anyone to come near this place. There's a huge perimeter, a huge boundary. And beyond that, you can go. And there are people who like to, do UFO spotting. So they go all the way to the boundary, the legal boundary of Area 51. They go there at night, and then they go there with binoculars and cameras and whatnot, and they try to look at the sky and see if there's some UFO sighting that will be, visible to them or whatever. And people have reported strange happenings there, strange craft, UFOs, and so on. So that's Area 51. But what exactly is it? So let's try and see. Now it's no longer that classified. I mean, you can find it on Google Maps, right? You can. So let's go to Google Maps and let's try and find Area 51. It's in Nevada, Colorado. Where is it? Area 51, Nevada. Let's zoom in. Let's first zoom out. Zoom out. Okay. Area 51. Now we're going to zoom in after turning on the satellite imagery. So Nevada, Area 51. Where is it? Once again, let's zoom in. Aha. So this is Area 51. Let's see where it is. Yeah, it's here. It's a dry riverbed or a dry lake bed. It looks like a lake bed to me. And as you can see, there are these runways over here. So clearly, it's a place where you can test aircraft of various kinds. If you see the length of the runway, it's pretty significant. The length of the runway, it's like 8 kilometers. Wow. Okay, maybe not, or maybe yes. Yeah, maybe. And there's another one hidden here. And there's more runways. And let's see if we find some UFOs here. Can we see some UFOs? What's in the hangars here? You won't ever see anything interesting because it's all very nicely hidden away. Okay. This is Area 51. These are conventional aircraft. Nothing special about these as far as we can see from here. This is a regular aircraft. I don't see any UFOs. What's this? It's a tower of some kind. What do we have here? What is this object? There's a shadow. It's okay. It's a satellite dish or something. So look, you don't really see any evidence of UFOs here. What are these things? Okay, that's whatever it is. It's not UFOs. What do we have here? Are they crashed UFOs? No, it's some kind of debris. And here we have some cranes, I believe. You can see shadows of cranes. So this is the test facility where the US military, the US government, or whoever it is, they test experimental aircraft. Like the SR-71 Blackbird was tested here in the 1960s or whenever it was, which is one of the iconic aircraft, one of the fastest aircraft ever to be built, right? The SR-71. So that is Area 51. Okay, it's a experimental test facility where the US government and other agencies test aircraft. And probably the stealth aircraft were tested there. What does a stealth aircraft like the B-2 bomber look like? It looks really unusual, right? Stealth bomber. B-2. I mean, this looks like a UFO. It looks very much like a UFO. Nowadays, people are used to this design, this flying wing design. But when it was being tested, let's say in the 1970s, 1980s, if somebody saw this, they would 100% believe that they've seen a UFO or a UAP for sure, because nobody at that time knew that that sort of aircraft design exists. So if somebody saw it at that time, even in the night time, they would definitely imagine that they've seen a UFO. And there must be some other kinds of aircraft also that we are not aware of, that perhaps are being tested there, which may look even stranger, right? So that's Area 51. It's a restricted facility, no longer secret, but restricted facility where experimental futuristic aircraft are tested. So that's the very clear explanation for why people see unusual things there. You don't need the existence of aliens to explain that. Right. So UFO alien narratives have always been associated with this Area 51, but it's most likely not what people believe it is. Okay. Rinigan says, the man who discovered the Loktak proto-galaxy cluster said that he encountered something alien in the sky in his childhood, and it inspired him to become an astrophysicist. His name is Dr. Romeo Leishram, I think. And he discovered this cluster, proto-galactic cluster. It's a cluster of, it's a set of 4 proto-galactic clusters. And it's very ancient, like it's about 1 billion years. It was formed about 1 billion or so years after the Big Bang, 1.2 billion. Let's quickly take a look at the Loktak proto-cluster. Loktak proto-galactic cluster. Okay, what do we have? Okay, it existed 1.2 million years after the Big Bang. Discovered by astrophysicist Dr. Ronaldo Leishram. The city of galaxies is being pulled together by gravity. It's named after Manipur's iconic Loktak Lake, and so on. So it's got what? How many? 4. How many? It's got 4 interconnected concentrations of galaxies, and it looks like the floating islands of vegetation on Loktak Lake in Manipur. Beautiful lake. And that's why, since he discovered this, he got to name it, and he named it the Loktak cluster. Right? So great job by Dr. Ronaldo Leishram, of course. And so I wasn't aware of about this story, that he saw something or encountered something unusual or alien in the sky in his childhood that inspired him to be an astrophysicist. Well, that's interesting. You often see strange things in the sky. So when I was a kid, I used to really enjoy spending a few hours in the night looking at the night sky. This was a time when you had very little, much lesser light pollution than what you have today. So you could actually see the sky. You could actually see the stars. And if you have a clear sky with very little light pollution, you're going to see all kinds of activity in the sky. You're going to see the stars out there, sure. But you'll see things. You will see satellites moving around. And if you spend a few hours, you're going to see them over and over. The same satellite will revisit the place after 90 minutes or whatever it is, right? So you will see satellites. If it's a nice dark night, you will see satellites every 5-10 minutes. You will see meteors. Meteors also, depending on the season, depending on the time of the year and so on, you may see a few meteors every hour. If you're lucky, you'll see spectacular meteors. Sometimes you will see spacecraft debris re-entering the atmosphere. Okay, dying spacecraft or defunct spacecraft re-entering the atmosphere. And they don't zoom out just like that, like a meteor. They're going to burn up slowly, gradually in the atmosphere. That's quite a sight to see. I've seen that a few times. Okay, maybe it's a booster of a rocket that's re-entering the atmosphere. Maybe it's a long defunct satellite that's finally re-entering the atmosphere, and it slowly burns up. It doesn't just zoom past you like a meteor. It slowly burns up and it lights up. Sometimes it's bright, sometimes it's not that bright, and it's just traveling above you. So you see all kinds of unusual things in the sky. You have to learn how to recognize them for what they really are. So I have spent countless hours as a kid observing the sky. I sadly, tragically, have never seen anything that I could classify as alien. I suppose the Dr. Lyshram was luckier than me, and he saw something that probably he could not explain. And when you see something like that, it either scares the hell out of you, or it inspires you to dig more into what's up there. Yeah, and so that inspired him to become an astrophysicist. So whoever it was, whichever alien it was, I would like to thank the alien for doing this. Okay. Somi says, can you tell about various methods through which humans could travel to other planets using the laws of physics with technology that's not within the domain of fantasy? Well, that's a great question. Using actual technology that's within the laws of physics, not fantasy. So what are the different ways humans could travel to other planets? Let's say we want to travel, let's say, to Pluto. Now, some of you may say Pluto is not a planet. Well, I don't care what you say. For me, Pluto is a planet. Okay? For me, Pluto is a planet. I don't care if it's classified as a planetoid, planetesimal, dwarf planet, minor planet, whatever. For me, it's a planet. So let's say you want to travel to Pluto. Mars, you can travel to Mars using your standard chemical rockets. What's a chemical rocket? A rocket that uses chemicals for propulsion. You can have various kinds of chemical mixtures. You can have hypergolic fuel. You can have hydrogen oxygen mixtures. The output is just very high temperature steam, right? There's no pollution in that. You can have hydrazine. You can have all kinds of fuels. Okay, so and you can have different kinds of fuels for different stages. You can have solid fuel for boosters. You can have liquid fuel for the cryogenic stages, and so on and so forth. So that's chemical rockets. That's what ISRO uses. That's what NASA uses. That's what the Chinese Space Agency uses. That's what SpaceX uses. That's what the European Space Agency uses. It's chemical rockets. That's the standard method of propulsion. And you could send humans to the moon using this. You could send humans to Mars using this technology. You want to send somebody to the moon, it will take you 3-4 days if you have a powerful enough rocket. If you have an ISRO rocket, it'll take you a month or two. If you have a NASA rocket or a SpaceX rocket, it could take you like 3 days to reach the moon. If you want to send humans to Mars using chemical rockets, it could take you about 8-9 months, depending on the time of the year. Because every 29 months or so, there's a launch window, which gives you the fastest travel time, because the two planets orbit the sun at different speeds. It takes different amounts of time for the two planets to orbit the sun, and there are times when they come close together. So that's when you want to launch, right? Based on when they're going to come the closest and the least amount of time it will take to reach Mars. So it will take 8-9 months using uh, a powerful chemical rocket to reach Mars. If you want to send a mission to Pluto using chemical rockets, could take you 10-15 years. 10 to 15 years to reach Pluto. So the last time we did that, on the only time we did that was New Horizons, which rendezvoused with Pluto, I think in 2015, right? New Horizons. When was the New Horizons spacecraft launched, and when did it rendezvous with Pluto? So it was launched in 2006 and it rendezvoused with Pluto in 2015. So it's 11 years, right? So, like I said, 10 to 15 years. It was 11 years for the New Horizons spacecraft, which was the fastest spacecraft ever launched. So, 11 years for that. So, if you want to send humans to Pluto and bring them back, it's going to take them like 2-3 decades. That's too long, right? So one method is chemical rockets. Do we have other methods to send humans to other planets? Well, you could use nuclear rockets. Rockets propelled by nuclear explosions, atomic bombs. Boom, boom. For that, you will need very massive, very robust rockets. But it certainly is a feasible way of traveling. And it will take you to Mars or wherever much quicker than chemical rockets. So this the feasibility of such technology was assessed, I think, in the 1970s or whenever it was. Dr. Freeman Dyson was involved in the project, the great Dr. Dyson of the Dyson sphere, who gave us the concept of the Dyson sphere. So he was involved in the project of exploring the feasibility of sending a rocket to Mars, and the rocket would be propelled by nuclear explosions. It will work. It can work. So that's another way of doing it. One is chemical rockets. The second is nuclear propulsion. Then you can have ion thrusters, which is a technology that certainly is within the realm of physics. And has it been tested? Ion thrusters, but you would need so ion thrusters will not take you beyond the atmosphere. You will need a chemical rocket first or second stage to take you out of the atmosphere, and then you can fire off your ion thrusters once you've escaped from Earth's gravity. Has anyone tested this? Has NASA tested ion thrusters? Yes, it has rigorously tested ion thrusters for decades, both in high vacuum ground chambers and in deep space missions. Okay, Dawn spacecraft, Psyche mission, and so on. Right. So you have that. Yeah. So ion thrusters can work. That's another technology. You could use light sails, but you don't need light sails to travel to other planets. Light sails can be powered by the sun's light. You can also use lasers to power light sails, very powerful lasers. So you could make that happen in a decade or so. Maybe the technology is about a decade away. So light sails are just sheets of metal, very thin sheets of metal, and you shine light on that. And light has a pressure. Light exerts a pressure on the light sail, on the sail, on the sheet of metal. It's called radiation pressure. Okay, because light is made of photons. Photons don't have mass, but they have momentum. If they have momentum, they're going to exert a force, an impact every time they hit a sheet of metal. So you can use light sails, or you could say as a means of propulsion. Now, if you have very high powered lasers on Earth or maybe in orbit, then you could use those lasers to shine very powerful beams of light on the light sail. That could accelerate the light sail to very, very high velocities, maybe 10, 20, even 30% of the speed of light. So using that, you could reach Proxima Centauri in 30, 40 years. Right? So these are different ways of traveling to other parts of the, let's say, solar system or beyond, using the laws of physics. Do we have anything else? Well, we have almost science fiction sounding technology, which is not quite science fiction. It's within the realm of physics. It's called the Bussard ramjet. The Bussard ramjet. Okay. So what? We'll Google it, of course. But what's it like? So you have a spacecraft that's in space. Okay, and it's got a huge magnetic field ahead of the spacecraft, and it scoops up the interstellar gas, which is very diffuse, but the interstellar space is not entirely vacuum. You have, well, protons, you have hydrogen atoms, and so on. So you scoop that up and you use that to power nuclear propulsion engines. That's your Bussard ramjet, okay? And that's definitely something that does not violate the laws of physics, but it requires engineering beyond anything we can, currently even think of manufacturing. So let's see this. Bussard ramjet. What happened? Let's try again. Bussard ramjet. So this thing here. So it's got a ram scoop. It will be much bigger than this. You can use magnetic fields to create a massive ram scoop, and then you use whatever you're scooping up to power your nuclear engine. Right? So it's certainly feasible within the laws of physics, but it's beyond the scope of anything we can engineer today. So these are different ways of potentially traveling across interstellar space, or maybe within the solar system also. Rahul Dunake says, hypothetically, if there is a cricket match played on Jupiter, how smaller would the boundary lines be? How fast would the ball be delivered? And would the ball's swing and speed be affected? Okay, so you have Jupiter, massive planet, the biggest planet of all in our solar system, right? And it's a gas giant. It doesn't have a surface. There's no solid surface that you can stand on Jupiter. It's just gas. So if you were to jump into Jupiter, you will never hit a surface. You'll dive into the atmosphere, and then the atmosphere will get thicker and thicker and hotter. Eventually, it will be so dense, it will be denser than water. So you may float in there, but you will boil. Okay? So there's no surface as such on the planet of Jupiter. But let's say hypothetically, the top of the atmosphere, let's say it's a surface. Let's say it's a surface you can stand on, and let's play a game of cricket on. So if that was the case, then what would you experience there? Can humans play a game of cricket there? Can humans even survive there? Let's say you have breathing masks and you have oxygen and all. How much gravity will you experience on Jupiter if there was a surface at the top of the atmosphere? Well, people may imagine that the gravity, okay, what's the mass of Jupiter compared to that of Earth? Okay, first of all, what is the mass of Jupiter compared to that of Earth? So Jupiter is 318 times more massive than Earth. Okay. So if that is the case, you may imagine that if something weighs 1 kilo on Earth, it must weigh 318 kilos on Jupiter. If something weighs 100 kilos on Earth, it should weigh 30,000 kilos. 300. Yeah, 30,000 kilos on Jupiter. Right. So if that is the case, no human being can survive there. But the fact is that a human being will not weigh 300 times more on Jupiter. A human being will weigh only 2.5 times roughly more than on Earth. That is very strange and counterintuitive, but it's very simple actually. Because what's the radius? Okay, let's say the radius, okay? What's the radius of Jupiter compared to that of Earth? So Jupiter's radius is 69, almost 70,000 kilometers. Okay? And Earth's radius is 6,000 kilometers roughly. So if you're standing on the surface of Jupiter, You are 70,000 kilometers almost from the center of mass of Jupiter. But on Earth, you just 6,300 kilometers from the center of mass of Earth. So if you're standing on Jupiter, because you're so far away from the center of mass, that's why the gravity you experience is not 300 times that of Earth. It's about 2.5 times that of Earth. So if you weigh 70 kilos on Earth, if you're standing on that imaginary surface at the top of the atmosphere on Jupiter, you will weigh about 175-ish kilograms, which is obviously it's a lot. But if you are a reasonably strong person, you may be able to survive that. Okay? So if you're on Jupiter, if you're trying to play a great game of cricket there, if you're all like 22 fit guys or girls or whatever, you may be able to somehow stand and walk on Jupiter. But if you're 70 kilos, you will experience a weight of 175 kilos roughly, which is going to stress you out very rapidly. It's going to create stress on your bones, on your spine, on everything. So even standing on Jupiter is going to be a struggle. Okay, it's like you've got a barbell with 100 kilos on it, and you're carrying it wherever you go. That's what you will feel on Jupiter. I mean, people can squat 100 kilos a few times. Maybe 5 sets of 5, you can do that perhaps. Maybe 5 sets of 10 or whatever, how strong you are. But you can't do it for 24 hours, right? Even if you lie down, there's going to be a tremendous amount of stress on your lungs, your heart, on your circulation. And you can't survive beyond, I don't know, a few hours, I suppose, with that sort of gravity. So if you go to Jupiter with the intention of playing a cricket match, you'll find that everything is incredibly heavy. What's the mass of a cricket ball? Let's find out. What is the mass of a cricket ball? Let's say it's 150 grams. Okay, let's say it's 150 grams. So on Jupiter, a cricket ball will weigh 2.5 times that. 15 to the 30, 375 grams or something, almost half a kilogram. Okay, your cricket ball will weigh almost half a kilogram. Your arm will weigh so much more. So I think it's gonna in your bat. Your bat is gonna weigh like 2.5 times what a bat normally weighs. So I think it's gonna be essentially impossible to play a great game of cricket on Jupiter. It'll be impossible to run with that amount of weight on you, right? So, so the fact of the matter is that a game of cricket is next to impossible on Jupiter. Setting the field and all, by the time your fielders reach their positions, they'll be like exhausted. If you ask somebody to deliver a ball, one ball, you're done, right? So it's going to be next to impossible. Forget about the swing of the ball. Forget about how fast it will be delivered. If the big question is, can anyone deliver a ball at all, right? So yeah, it's very tough. But if you go to Saturn, okay, first of all, I am saying Jupiter's gravity is 2.5 times that of Earth. Let's double check. Let's fact check that. Is Jupiter's surface gravity approximately 2.5 times that of Earth? Yes, that is correct. 2.4 to 2.5 times that of Earth. But Saturn, it's less than 1.1 times that of Earth. Okay. What is Saturn's surface gravity compared to that of Earth? It will be less than 1.1 times. Come on, Google it. Yeah, there we have it. It's about 1.065 times that of Earth. So if you weigh 100 kilos on Earth, you'll weigh 106.5 kilos on Saturn. So if you play a game of cricket on Saturn, I suppose you can play a little bit more weight there. So it's feasible on Saturn if you create a surface on top of the atmosphere of Saturn. It will be almost the same as the kind of cricket you can play on Earth. Okay, it won't be that difficult. You can play a full T20 game or something. But on Jupiter, it's very difficult. Very difficult. Okay, Sunil C says, how practical and feasible is it to terraform some other planet? Okay, terraforming. What exactly is terraforming? That's the first question we have to ask. Terraforming is transforming the characteristics of a planet's surface and also its atmosphere to make it suitable for human habitation. That's what terraforming is. So let's take the example of Mars. Okay, the closest planet to us is Venus, but that's way too different from Earth. Very different from Earth. Venus has it's almost the same size as Earth, but it's got a enormously thick atmosphere. On the surface of Venus, the atmospheric pressure is about 300 times that of Earth, and the heat is intense. It's so hot on the surface that it will melt lead. Okay, and the atmosphere is noxious. It's corrosive. It's toxic. It's got all kinds of horrific chemicals. It rains sulfuric acid. There's volcanism all over the place. There's lightning all over the place at all times. It's impossible to even imagine going to the surface of Venus. Forget about terraforming it. So we will not discuss Venus. We'll discuss Mars. Mars, it's a smaller planet compared to Earth. You will weigh significantly less on Mars compared to Earth. Mars does have an atmosphere, but it's much thinner than other atmosphere. Most of the atmosphere is carbon dioxide on Mars. Very little oxygen, if any at all. And the atmosphere is pretty thin. And sadly, Mars has an almost non-existent magnetic field, which means that it is constantly bombarded by cosmic rays and solar wind and all that. So if you go there unprotected, you're going to be exposed to all of that, and you will have a very high chance of having your DNA mutated in nasty ways, which essentially means cancer, right? Unless you take adequate precautionary measures of shielding yourself from what's coming outside of the atmosphere. So there is that. Then there's no water that you can see on the surface, or maybe there is some, but that's frozen. So there's water on Mars, but it's frozen in the polar regions, in the ice caps. There's subsurface water also, but that's also frozen. But sometimes you see trickles of water sometimes. So Mars is kind of in the sun's habitable zone. And in the past, you had large quantities of water on Mars. You can still see the remnants of erosion, the remnants of water channels, of rivers, of oceans, canyons, waterfalls, all of that you can see there. But all of that water disappeared because the planet lost its magnetic field. So if you want to terraform Mars, what do you need? You want to make it like Earth. You can't change the gravity or the mass of the planet, but you can change the characteristics of the surface and the atmosphere. So one issue in Mars is that it's very cold. What's the average temperature on Mars? Must be around -30, right? Let's see. What is the average temperature on Mars in degrees Celsius? -30? Oh, -60. Oh, that's terrible. Right? So it's because it's got a very thin atmosphere. So the first thing you have to do to terraform the planet is to increase the temperature of the planet. How do you increase the temperature of the planet? You somehow find a way to inject, let's say, greenhouse gases into the atmosphere. Water vapor, carbon dioxide, and so on. There's already carbon dioxide, but we need more of it. We want water vapor. We want more clouds which will retain heat inside the atmosphere, in the atmosphere, and so on. So one way to do it is somehow push a lot of water vapor into the atmosphere, or you can, create a small Dyson sphere kind of thing, a ring of mirrors around the planet, which will take the sunlight and focus it back onto the planet's surface. That will heat up the planet, right? And maybe bring it to like 10, 15, 20 degrees Celsius, which is fine for human survival. So you could encircle the planet with a ring of mirrors, large mirrors that will shine the sunlight 24/7 back onto the surface of the planet. That's one thing you could do. That would also melt the water in the polar regions and once again flood the planet, which is great because now we have flowing water. So that's what you could do. Now, the soil of the planet It's not conducive for agriculture. So you have to somehow chemically alter it, or find ways of altering the composition and nature of the soil. So you will need some chemical processing and all that, or something else. And all of these things you have to do at a planet wide scale. Just those mirrors, this gigantic array of mirrors in orbit around the planet, maybe in a polar orbit or whatever, that is beyond our capacity right now, right? How do you manufacture such enormous mirrors and then bring them, transport them all the way to Mars and put them in orbit and create a whole array of mirrors around the planet? Right now, we don't have the means to do that, but in the future, maybe we could do that. Another cheap way of doing, of having liquid water on the planet, is to nuke the poles, nuke the two polar regions of the planet. That's what Elon Musk suggested once or twice, maybe humorously. Nuke Mars. That way you can have liquid water. So it can all be done theoretically. There is nothing in the laws of physics and chemistry that says that you can't do it. But that is an engineering project on a planetary scale. And we currently lack the resources and the means to make it happen. Maybe in the future it will be possible. Maybe in 100, 200 years, maybe we'll have the means to do that. But right now we don't. But it certainly is theoretically and technically feasible to do that. Sunil C says, will humans ever be able to mine the asteroid belt? So, what is this asteroid belt, first of all? The asteroid belt is a region between the orbits of Mars and Jupiter, where you have a whole plethora of space rocks. A tremendous number, million. How many asteroids do we have? So you have multiple asteroid belts, actually. But we're talking about the main one, which is between the orbits of Jupiter and Mars. There are also the Trojan asteroids and so on and so forth, which we'll not discuss here. There's the Kuiper belt, so much more, but we're talking about the belt of asteroids between the orbits of Mars and Jupiter. So that's a very large number. Let's see how many asteroids we have. How many asteroids are estimated to exist in the asteroid belt? Millions, billions? Okay, 1.1 to 1.9 million asteroids that are 1 kilometer or larger in diameter. If you include smaller space rocks, there are likely millions to hundreds of millions of tinier asteroids and pebble-sized fragments. Okay, so that's the asteroid belt. But the numbers are very large. But if you go to the asteroid belt, you will find almost nothing. There's tens, hundreds, thousands, maybe millions of kilometers between any two asteroids. It's essentially almost empty. It's not like if you fly through the asteroid belt, you're going to bump into asteroids and crash or whatever. It's almost empty. But it's not as empty as other parts of the solar system. So maybe there was an ancient planet there that it's a failed planet, but there's a big pile of rubble there floating around. So that is the asteroid belt. And there are some asteroids which are pretty large. Some of them are pretty nasty and naughty, right? 66 billion years ago, we encountered such an asteroid. It impacted our planet and killed off the non-avian dinosaurs. We've had other impacts in the past. Millions of, tens of, hundreds of millions of years before the dinosaur killing asteroid. So we've had these things that happen once in a while. But mostly the asteroids mind their own business and stay between the orbits of Mars and Jupiter. And some of them are pretty big. Many, like we saw, about a million, more than a million, are larger than 1 kilometer in diameter. Some of them are tens of kilometers in diameter. And these asteroids, they contain minerals, interesting minerals. There could be asteroids that contain large quantities of gold, for example. There could be asteroids that contain large quantities of copper, iron, rare earths. So there are different kinds of asteroids. There are metallic asteroids. There are carboniferous chondrites and so on and so forth. Some asteroids are large, but they're just a pile of rubble, and so on. But some of these asteroids can be pretty valuable if they are metallic and contain metals that are valuable. Not just gold, but also copper, iron, nickel, whatever. So the question is, will humans one day be able to mine the asteroid belt? Well, theoretically it's possible, but is it feasible? Is it economically viable? So if you want to mine an asteroid, first of all you have to know which asteroid to target, because there's millions of them. Millions of them. So how do we know which asteroid contains something that we're looking for? Let's say gold, for example. How do we know which asteroid has large quantities of gold? Sitting on Earth, how do you figure it out? It's very hard to do that. It's very hard. So right now, I'm not even sure if we have the means of deducing an asteroid's composition from so far away. And secondly, even if we discover that so and so asteroid all the way there contains a large amount of gold, and let's say we want to go and get that, you're going to have to go all the way beyond the orbit of Mars and before the orbit of Jupiter. Okay. And what's the orbit? What's 1 year on Jupiter? What is 1 year on Mars and 1 year on Jupiter? So on Mars, it's 687 Earth days, Jupiter 4333 Earth days. Okay, so what's 1 year in the asteroid belt? So could be, okay, 3 to 6 Earth years. Okay. Right, okay. The point is it's very far. The point is that it's very far. So you would have to send a spacecraft that goes all the way beyond the orbit of Mars, locks onto the asteroid, latches onto it, lands on it, and then does mining operations on the asteroid, extraction of what you're looking for, maybe purification, because we don't want to bring all the rubble back to Earth, purification, and then transports all of that back to Earth. That's a pretty complicated and expensive operation, right? And most of the asteroids are just rock. They're just rubble. They may even contain things we don't want to bring back to Earth. Who knows? Organic compounds, maybe something more than organic. We don't know. So I think it's definitely technically possible, definitely feasible, definitely doesn't violate the laws of physics, but it's monumentally expensive, and it's very hard to reach asteroids which are so far away. Can be done. It's been done in the past. But even if you can reach an asteroid, how do you transport mining equipment all the way there and then do mining operations in microgravity and extraction in microgravity and purification in microgravity? How do you do that, all of that in situ over there? So it's possible, but right now we don't have the means to do that. Maybe in 100, 200 years we may have the technology, but right now it is still beyond us very much. Okay, Vladimir Putin and Ayush Singh, they have a question that's clubbed together. Real Vladimir Putin says, why has the focus shifted from Mars to the moon? What are the resources that the moon offers us that Mars doesn't? Ayush Singh says, what exactly will the colonization of the moon? What is the purpose of the colonization of the moon? Is it for resources? What does the moon have to offer that has suddenly shifted mood attention away from the Mars to the moon? So it's essentially the same question asked in two different ways. So yes, I mean, Elon Musk has been saying that we need to occupy Mars. His famous slogan is Occupy Mars, right? Humanity, a multi-planetary civilization. And he has been developing his most powerful rocket, SpaceX rocket, Starship, with the express purpose and objective of taking people to Mars. And that's been his mission for a very long time, for more than a decade. But now he has made a U-turn of sorts. He says, we're going to focus on the moon first. So why has the focus suddenly shifted from Mars to the moon? Even NASA is planning to send humans to the moon before the end of this decade, in the next 2 or 3 years. And before it sends humans to the moon, it's going to send equipment and supplies to the moon, right? So the focus is on the moon now. Even Elon Musk's mood is focused from Mars to the moon. Why is this the case? There are multiple reasons for it. First of all, the moon is right next door. If you have a powerful enough rocket, it will take you 3 or 4 days to reach the moon. 3.5, 4 days to reach the moon, right? So it's not far. Secondly, so it's easy. It's not as complicated and complex a mission sending humans to Mars. That one-way trip is 8 or 9 months, and coming back is another 8 or 9 months, or more, depending on whether you return immediately or you spend a few days there or whatever, right? So it's a pretty complicated mission, keeping humans alive for that duration, landing them safely on Mars, very difficult because of the thin atmosphere, and then having them take off again from Mars and come all the way back to Earth. Very complicated stuff. Moon, it's been done before. The moon, it's not that complicated. It's significantly less complicated than sending humans to Mars. So that's one reason. First, achieve this local win. Let's get back onto the moon. And the moon is now experiencing renewed attention, not just from the Americans, but from the Chinese. The Chinese have been sending very sophisticated missions to the moon, missions of increasing complexity. They sent a lander on the moon. They sent a rover on the moon. Then they sent a lander to the far side of the moon and a rover to the far side of the moon. Then they sent a sample return mission, which means a mission that lands a lander on the moon. Then you have a rover or whatever it is that collects moon rocks, and then it takes off from the moon and returns the samples back to Earth. That's a pretty complex mission, right? So the Chinese have been progressing step by step by step, missions of increasing complexity, and they are very ambitious. So there's a race between the Americans and the Chinese to get back to the moon. And the Chinese have already sent humans to space. They already have a space station where they can send humans. So they already have significant experience and the know-how about how to keep humans alive in space. The Russians also had that. But when was the last time a Russian went to space? I'm not sure. But the real question is why, apart from the fact that the moon is easier, why focus on the moon? Are there resources there? Is there something else there? So one thing is that there are valuable resources on the moon. One valuable resource is water. Water is crucial for life. Without water, there's no life. And we know there is significant water in the polar regions of the moon, especially the South Pole region. How did we discover this? We discovered this in 2010 or 2011. It was the Chandrayaan-1 mission that discovered water on the moon for the first time. The Chandrayaan-1 mission, which was an Indian mission, it had a moon impactor. It released an impactor that went and smashed into one of the craters in the South Pole region, and then it studied what came out of that impact, the debris ejected from the impact. And when it did the spectrographic analysis of what came out, there was water. And now it's confirmed that there is significant quantities of water in the permanently shadowed regions of the South Pole, of the craters in the South Pole region of the moon. So if you want to have a moon base, if there's no water on the moon, as was earlier believed, then you would have to transport water from the Earth to the moon. And water is heavy. That significantly increases the costs of keeping humans on the moon. But if you have thousands, maybe tens, maybe millions of tons of water on the moon, let's see how much water is estimated to be on the moon. How much water is estimated to exist in the South Pole region of the moon? How many tons? Hundreds of billions of kilograms, hundreds of millions of metric tons. So if you have that, okay, if you have hundreds of millions of metric tons of water in the South Pole region, then you want to get there and capture the region. It's a geopolitical capture. So the Americans are probably going to be the first to land there, and they will set up a permanent base there, and that base will have a perimeter, which will be exclusive to the US, of course. Then you set up a second base, third base, fourth base. You do it as fast as possible, and you capture the entire South Pole region, and then you say this is sovereign American territory. So you capture all the water. Then if the Chinese come there, you will sell them the water. You want water? Yes, you pay. If the Indians come there, they'll say, you Indians, if you want water, you pay. Water is like gold on the moon. So if you want the water that belongs to us, then you pay for it. $10 million a kilogram or so, whatever. Yeah, that sort of thing. So that's great. That's one reason. That's one super valuable resource you have on the moon. Another super valuable resource on the moon is helium-3, which exists in very large quantities in the moon's regolith. What's regolith? The topsoil, you could say, of the moon. Okay, that's what you call the moon's regolith. The moon dust, the surface of the moon. So there's no atmosphere on the moon, nothing of any significance. And the moon has been bombarded for 4.5 billion years by solar wind and cosmic rays. Because of that, you have a large quantity of helium-3, a spatial isotope of helium that exists in the regolith of the moon. So your typical helium atoms have an atomic mass number of 2, because the atomic nucleus is 1 proton, 1 neutron. That's an atomic mass number of 2. But there is a special isotope of helium called helium-3, which contains an additional neutron. So its nucleus is 1 proton and 2 neutrons. Now this helium-3 is going to be a fantastic fuel for future fusion reactors. So right now, we have fission reactors, nuclear reactors on the planet. But in the next 10, 20 years, fusion will become a thing. And eventually, we'll have commercial fusion reactors in the next 20, 30 years. And when you have those, helium-3 is a fantastic fuel for that. So if you can extract helium-3 from the moon and bring it to Earth and power fusion reactors, you have essentially inexhaustible fuel sources. So that's another reason why the moon is valuable. And you will have all kinds of other resources too on the moon. Okay, the moon's composition is not very different from that of the Earth, because the moon came out of ejecta from the Earth. Because our planet was in the very infancy of our planet, we suffered a collision with an ancient protoplanet. Kaboom. And that ruptured our planet and shredded our planet, and a lot of ejecta was splashed out into Earth's orbit. So our planet absorbed the impactor and ejected a tremendous amount of splash out material, which eventually coalesced into one single body called the moon. So the composition of the moon is similar to that of Earth, which means that it could have, valuable minerals, metals, whatever. So you could one day have a massive mining industry on the moon. Maybe in a few decades, you will have lights on the moon. If you look at the moon, you will see artificial lights there. So because of these reasons, the moon is an extremely tempting target, an extremely valuable place to colonize first, colonize commercially and geopolitically. So the first 2-3 nations that will make a move on the moon will essentially determine the future of what happens on the moon, and the Americans are determined to be the first to do that. So in the next 2-3 years, the first American moon base will most likely come into existence. That's why there is this renewed focus on the moon, this great moon rush that we are seeing right now. Okay. Daksh Khemka says, do you think that by throwing money, tremendous amounts of money, can we brute force India into the space race through the private sector? Like hire all IIT students and push them into rocket science, working maybe under a new private company. And then in 1 or 2 years, from scratch, can we send humans to space? That's the question. So can we accelerate the program, the space program, and send humans to space in just 1 or 2 years through brute force, tremendous amounts of money, hire all the IIT students, as many as you need, create a new private company, give them all the resources, all the money they need, and in 2 years we send humans to space. Is that possible? The answer in short is no. Money alone will not be enough of an accelerant. We can certainly, if we throw enough money, in a couple of years, you can start launching rockets. Okay? Launching a rocket is not that difficult. It's not that complicated. It's certainly less complicated than trying to build a jet engine. A rocket is a pretty simple vehicle, actually, right? If you have the propellant and if you know the basic, aerodynamics and all that, you can launch a rocket. Of course, it will blow up the first 2-3 times. That happens, okay, but eventually you'll get it right if you've got the right kind of talent. So if you have an accelerated development program where you launch multiple times a year, let's say 10 times a year, you launch one, the first rocket you ever launched, maybe it goes 3 kilometers up and then crashes or blows up, and you figure out what went wrong. Then very quickly you fix it, and in 1 month you build a new rocket which fixes that original problem. You launch again. This time, let's say it goes 20 kilometers and then blows up. So then you find new telemetry data, and then you figure out what is this new problem. You fix that. In 1 month, you launch one more rocket. This time it goes 80 kilometers and dies. So now you figure out, okay, it was not this stage, it was the cryogenic stage where something went wrong. Maybe fuel was sloshing around or whatever. So you understand the problem, you fix that. And the fourth launch in 4 months' time, after the first launch, it actually makes it to orbit. Okay. So now that you have a rocket in orbit, you do another test after month 5. You put a satellite as a payload in the rocket, and you see if you can actually deploy the satellite to space. Maybe it works, maybe it doesn't work. So you launch aggressively with very tight schedules and very aggressive development. Within 1 year, you can have like 3 satellite launches, maybe. Okay. Then you improve upon the rocket and do things, tweaks or whatever. And then you do like 10 more launches the next year. And once, let's say, you have a rocket that has successfully launched 10 consecutive missions into space with your smallish satellites, then you build a bigger rocket. Because your first rockets are going to be pretty small. They're going to be able to take maybe 100 kilograms of payload into orbit or something like that. So once you have done the conceptual thing, then you make a bigger rocket. Maybe this time it's going to be able to take 500 kilograms into orbit. That may fail a couple of times, but you get that right in the second year. Then the third year, you want to send a 1-ton rocket, a 1-ton payload into low Earth orbit. So you build more and more powerful rockets. And eventually you're going to have a rocket that can take 2-3 humans into space. It will be that powerful. But you will not send humans immediately to space until you have like at least 10 consecutive successful launches. Because a satellite being lost is no big deal, but human lives are super valuable, right? So you want, and it's not enough to have a rocket that has successfully been launched 10 consecutive times. Now you need a space capsule. You need a capsule, essentially, that can keep humans alive in orbit and then bring them safely back to Earth. It should also have fail-safe mechanisms where if something goes wrong with the rocket, there'll be an automatic escape or something. So that takes time to develop. You can develop that in parallel with your rocket, but I would say that the minimum amount of time you will need, it will be like 5-6 years minimum. No matter how much money you throw at it, no matter how many rocket programs you develop in parallel, you will need 5-6 years at least. An actual reasonable timeline is about a decade. Okay, that's how we do it step by step. You don't want to put human lives in danger without testing everything very rigorously. So ISRO launches like 3, 4, 5 rockets a year. It's a very slow glacial progress. But if you have an accelerated, aggressive development timeline, then you can probably send humans into space in 6-7 years. 6-7 years should be fine. 2 years, it's not practical at all. 6-7 years with aggressive, accelerated timeline with plenty of money and talent available, 6-7 years is feasible. 2 years, it's not advisable at all. Not possible. 6-7 years is possible. And that's certainly feasible in India. We have the talent, we have the money, but we lack the will. Anyway, we'll not discuss that here. Okay? Okay. Rahul Dunake says, does the colliding pulsars create all the gold that's present in the universe? Interesting question. Gold. We have gold on our planet. It is super rare, super pretty. And because it is pretty and rare, it's valuable. And it's valuable because it's rare, right? It's a very scarce metal. And that's why it's valuable. And that's why it is the store of value on our planet, right? Now, how is gold created? I mean, if you look at the sun, I'm not advising anybody to look at the sun directly. It'll destroy your eyes. But when the sun shines upon you, there's probably more than 1 trillion tons of gold in the sun. Okay, let's figure out how much gold actually. Let's double check that. How many kilograms of gold are present in the sun? How much? How many kilograms? Oh, 10 raised to 21 kilograms, trillions of metric tons of gold, weighing more than all the water in all of Earth's oceans. But it's a minuscule fraction of the sun's total mass. So there's all this gold in the sun. All this tremendous quantity of gold on the sun. The question is, how did it get there? Did the sun produce the gold through nuclear reactions, fusion? No. The sun did not produce it. The sun inherited it. Our solar system was formed from a protostellar disk of dust and gas. Where did that come from? It came from the death of another star, a star that existed long ago, billions of years ago. And it died. It went kaboom, supernova. It released all this debris, dust, gas and dust and all that. And that eventually coalesced through self-gravitation into a protostellar disk, which eventually became the solar system. The center was this big mass of gas that coalesced and eventually spontaneously ignited into nuclear fusion because of its mass. And there was gold there, which came from the previous star. So the sun inherited the gold. But the question is, how was this gold produced in the first place? So there are multiple mechanisms through which gold is produced in the universe. See, heavy elements are produced through nuclear fusion. Stars are massive fusion reactors. The standard nuclear reaction that's happening in most stars like our sun is the fusion of hydrogen atoms, hydrogen nuclei into helium nuclei. Okay? Protons getting squeezed together and forming helium nuclei. Okay, a helium nucleus is not one proton, one neutron, it's two protons. And helium-3 is two protons, one neutron. Okay, anyway. So it's a fusion of hydrogen into helium. And when two hydrogen nuclei fuse, they release a tremendous amount of energy, and that is what gives rise to the sun's light and heat. So the sun is just fusing hydrogen into helium. But eventually, when stars run out of hydrogen, they start fusing helium and producing heavier and heavier elements. Eventually, you have silicon, which is being converted into iron. There's neon in between, there's carbon in between, there's oxygen in between, there's eventually silicon that is being fused, that is being produced. And then when silicon nuclei are being fused into iron, that is the death of the star. Because producing iron consumes more energy than it releases. So suddenly the outward push that was supporting the weight of the star disappears. And the star implodes upon itself. And depending on the mass of the star, it can end up as a white dwarf if electron degeneracy pressure is enough, which is the Chandrasekhar limit, 1.44. If it is more than the Chandrasekhar limit, then it becomes a neutron star. If neutron degeneracy pressure is sufficient to prop up the star, and that's the Tolman Oppenheimer Volkoff limit, 2 point something solar masses, 2.3, 2.0 to 2.3 solar masses. And if the star's mass is more than that, end of story. Goes dark, black hole. But let's say let's say it goes supernova. It implodes and then it explodes. So that implosion process and then the explosion, that creates a tremendous amount of pressure. And that's where, for a brief amount of time, for a few milliseconds, you'll have heavy elements being created. Briefly. Heavy elements like lead, uranium, thorium, gold. So that's one mechanism through which gold is created, through neutron capture. It's a process called neutron capture, nuclear physics. So that's one mechanism. Another mechanism is the merger of two neutron stars. What's a pulsar? A pulsar is a certain kind of neutron star. It's a neutron star that's spinning very rapidly. Okay, very rapidly. That way. And it gives off massive amounts of electromagnetic radiation, radio waves, and so on and so forth. And you can detect them on Earth. And that's incredibly precise, like a metronome. Beep, 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 beep. You have pulsars that give you radio waves once every few seconds. Like every 2 seconds, you'll hear a beep, 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 beep. Extremely precise, brilliant natural clocks, essentially. You have pulsars that spin very fast. There are millisecond pulsars. There are microsecond pulsars, and so on and so forth. So pulsars are essentially neutron stars. Then there's magnetars, which are highly magnetized, monstrously magnetized neutron stars. You don't want to be anywhere near a magnetar. Anywhere near a magnetar. You don't want to be. So these are different kinds of neutron stars. So when two neutron stars collide, a neutron star is a corpse. It's essentially a gigantic atomic nucleus. It's got the mass of, let's say 2 suns. The mass of 2 suns, but the size of a city, 10 kilometers something. Okay, and it's just neutrons and a very exotic, weird layer on top. Okay, and nuclear pasta inside, which is extremely exotic and strange nuclear states inside of it. And let's say 2 neutron stars collide. They don't just go wham at each other. They will orbit each other for a few million years. The orbits will get closer and closer, and eventually they will collide. And that collision is extraordinarily energetic, and it's explosive. And in that brief fraction of a second when the explosion happens, there is a process, once again, neutron capture, where light elements absorb neutrons and become heavier elements. And that's where you have elements like uranium, thorium, and gold, etc., being produced. Okay, so that's another. This collision is called a kilonova. Kilonova. Okay, scary stuff, frightening stuff. Kilonova, and that produces a large quantity of these heavy elements: uranium, thorium, not plutonium, but gold, and so on. So that's another way. And then you have magnetars, which give rise to gigantic flashes. That also gives rise to neutron capture, and you have the production of heavy elements such as gold. So you have supernovas, you have the collisions of neutron stars, and you have magnetar flashes. These are three mechanisms via which gold is produced in the universe. I can't think of any other mechanisms. So whatever gold you have, it either came from a shocking supernova explosion, or an even more shocking kilonova, or from a magnetar flash. That's how you have gold and uranium and thorium on our planet. All right. Okay, let's take a couple more questions. Real Vladimir Putin says, why is the Big Bang considered to be the best model about the origin of the universe so far? Well, because it matches experimental evidence. Not just that, what are the pieces of evidence that we have? So a model is considered to be good if it matches the evidence, or if it's able to explain what we see observationally. So in the 1920s, the great astronomer Edwin Hubble discovered that the universe is expanding, and the expansion is accelerating, right? So it's just logical that if we turn the clock backwards in time, it means that if we turn the clock back, the universe is then contracting, which means that if the universe is expanding and the expansion is accelerating, it means that in the past the universe was smaller, and the further back in time you go, the smaller it was. Which means that if you calculate properly, about 13.8 billion years ago, it was a dot, the so-called Big Bang singularity. So that's one piece of evidence. The second thing is that if you calculate, okay, the kind of radiation that should be present in the universe and so on, based on the Big Bang theory, then it says that there should be a cosmic background radiation, which should have a certain temperature and a certain kind of distribution. And physicists hunted for that for decades. And then Penzias and Wilson stumbled upon it. So that is the CMB, the cosmic microwave background radiation, which has a temperature of about 2.7 or something Kelvin. And its distribution is precisely what you would expect based on the calculations and the predictions of the Big Bang model, right? Then you have the abundance of primordial elements. Okay, so if you look at the primordial elements in the very early universe, if you look at the spectra of very ancient stars, some of the first stars in the universe, then you find that there's a ratio of hydrogen to helium, 75 to 25, which is precisely as the Big Bang model predicts, and so on. You can go on and on like this, but essentially that's what it is. So all the evidence that you see, it precisely matches what the Big Bang model tells you should exist in the universe. And that's why it's considered to be the best model of the origin of the universe so far. Okay, let's take a couple more questions. What is a singularity? Well, there's okay, that's a pretty fundamental question, and the answer depends on which domain we're discussing. Are we discussing AI? In that case, a singularity is a certain kind of thing. It's where an artificial intelligence acquires consciousness and becomes, it may not acquire consciousness, but it becomes more advanced than human intelligence. So that's the AI singularity. But we're not discussing that here. You are discussing a physical singularity. So let's discuss physical singularities. There are two classes of, let's say, physical singularities. One is a mathematical singularity, one is an actual physical singularity. So in mathematics, what is a singularity? In mathematics, a singularity is where you have a mathematical function or an equation or a geometric graph that is no longer smooth. No, that's not. Where you have essentially division by zero. Okay? It breaks down. It's discontinuous, it is not well behaved, and it is essentially, it gives you infinities. So wherever you have this happening to a mathematical equation or a mathematical function or a geometric curve or graph, where you have this sort of effect, that's called a singularity in mathematics. In physics, a singularity is what you find at the core of a black hole. Okay? At the heart of a black hole. Let's say it's a non-rotating, non-charged black hole, a Schwarzschild black hole. And then at the center, there is this point. A point where you have infinite density, you have infinite curvature of space-time, and zero volume. That's a division by zero. That's a singularity. It's unphysical. It makes no sense mathematically or physically. But the equations throw that up. Which equations? The Einstein field equations. They throw up these mathematical monstrosities, which is an indication that the equations are flawed. There's a minor flaw somewhere. We need to figure out what that flaw is. So that's what a singularity is, okay? In physics and in mathematics. Okay, before we get into the live chat or super chat, let's take one more question. Amisha says, do you think free will exists? And is everything predestined? Well, that's that's a fundamental question. It's a question that humans have asked themselves for thousands of years, I suppose. Does free will exist? Well, in our experience, we all have free will, right? We decide what we want to do, and we decide what we like, and what we don't like. If I want to drink water now, I shall drink water. Here we have it. So I drank water of my own free will. I have chosen and selected these questions. Right? That's again free will. So as far as we see, we seem to have agency, we seem to have free will. But if you look at it from a physics perspective and a mathematics perspective, Well, we just discussed the Big Bang, that we know that the universe is expanding, the expansion is accelerating. So if we go backwards in time, it means the universe was smaller and smaller and smaller, and it all began with the primordial expansion of space-time 13.8 billion years ago, which we colloquially called the Big Bang. So let's say you are there just at the moment of the Big Bang, where the first initial expansion happens. Okay, maybe 1 Planck second, 1 Planck time unit after the expansion happened. So you have all this pure, almost pure energy, photons, and all that, and you know the positions and momenta of all these photons and all the primordial particles, and you know in what direction space time, I mean, how the space time is expanding. So if you know the initial positions and momenta of all the primordial particles that just emerged from the Big Bang, then you can calculate their positions anytime in the future. You can, and if you know the forces that existed, okay, you had at that time a grand unified force. That's what we believe. We don't have 4 separate forces: electromagnetism, strong force, weak force, and gravitation. We didn't have that. We had one grand unified force. So if you understood that force, and if you knew the positions and momenta of all the particles at the time, then you can predict everything billions of years into the future. Okay, you will need a very strong hypercomputer to do that, but you can do it. And of course, there is uncertainty, which is introduced by quantum mechanics, because quantum mechanics, you have randomness in quantum mechanics, but that is inherent randomness. It is statistical randomness. But if so overall, you can predict to a very good approximation what the future is going to be like. I mean, all the particles, they are governed, their motions and their evolution in space and time is essentially determined by differential equations. If you know the differential equations, you can predict the future. So eventually you will find that particles come together, coalesce, and become atoms and molecules and chemicals and proteins and life forms. If you have a powerful enough computer, you can predict all that. And maybe all of this, what I'm saying, is something you could have predicted in the past. So if you look at it from that perspective, there's no free will. Whatever we are doing, we imagine that we have free will, but actually we are simply programmed by the initial state of the universe and the differential equations that govern particles. We are programmed to do what we are doing. So we imagine we have free will, but maybe we don't. So that's one picture, one perspective. The other perspective is that from our experience, we seem to have free will. So the jury is still out there. Okay, maybe the universe is super deterministic. Everything is predetermined. We just imagine. We have the illusion of free will. So what's the true answer? We don't know. Okay, we should not imagine that we know everything about the universe. We know next to nothing about the universe. Whatever we know is very rudimentary. And that's why I would say that I don't know the answer. Nobody knows the answer. Some people are certain they know the answers. You should be careful about those people. People who imagine that they know everything, they typically know very little. So I would say that the answer is still out there, and we don't have the answers. All right, let's see now. That's me done with the questions I selected. There's still a few more, but okay, it's already 2 hours 15 minutes. So let's see whether we have any super chats. We have a few. Looks like it's gonna end soon today, which is all right. Okay, let's see what questions we have in the super chat. Satyajit says, if aliens are out there, then why haven't we found any von Neumann probes? Most likely locations for life in our solar system: Mars, Europa, Enceladus, Titan. I kind of answered all these questions, but let's take it again if you want. First of all, most likely locations for life in the solar system: Earth. Okay, Mars, there could be life possibly, maybe below the surface or something, but less likely, because we don't have too much flowing water on Mars. We have frozen water, and maybe if you had life in the past on Mars, and if it got frozen, if you thaw it out, maybe it could again revive itself or something. Maybe it's unicellular microscopic life, maybe multicellular microscopic life. So there is a small chance of maybe there still could be life possibly on Mars, and maybe there's a small chance there was life on Mars in the past. But we're not talking about today. I think the chance of life still being there on Mars is small. Europa, Enceladus, Titan, I think the chance could be higher than that of Mars, because Europa and Enceladus, they have subsurface liquid oceans, which means the temperature is higher than 0 degrees. And that would tell you that there is a possibility of life, depending on the chemical composition, what other chemicals are present in that ocean, which we don't know right now, but we can go and find out someday. So I think Europa and Enceladus, there's possibility of life. Titan, there could be life, but a very different form of life. Very cold life, hydrocarbon-based life, but certainly possible. Now, the first question you asked is about if aliens are out there. Well, the thing is that we don't know if aliens are out there, right? We don't know if aliens are out there. And even if aliens are there, how do we know whether they're intelligent enough to send von Neumann probes? Von Neumann probes are these self-replicating spacecraft that travel to various parts of the universe and seed the universe with life, right? That's what a von Neumann probe is. So it may not seed the universe with life, but it will go to various star systems, and wherever it finds a habitable planet, it'll relay it back to the home planet, so that you can send more probes there, or maybe humans there. That's a von Neumann probe. Why have we not found it? Maybe aliens don't exist, or maybe intelligent aliens don't exist, or maybe intelligent aliens exist, but space is too large. Maybe they've sent probes, but they haven't reached here yet. Or maybe they haven't sent probes in our direction. Ask yourselves this question, my friends. Have humans sent von Neumann probes anywhere? We haven't. We are out there, but we haven't sent von Neumann probes anywhere. So maybe the aliens are like us. So there are multiple explanations as to why we haven't found any of these von Neumann probes. Yes. Sharma says Greek food superior to dal, chawal, and Indian food. Is that a question? Is that a statement? Are there aliens in here? We're discussing aliens here, and you're discussing Greek food. Greek food is superior to dal, chawal, and Indian food. It's not a question, it's a statement. All right, sir. Thank you for sharing your knowledge about Greek food. Greek food is Mediterranean diet. Yeah, it's nice. It's nice. Superior, well, it depends on what you mean by superior. Online Vipasha says, are there any facts or intriguing details in the files launched by the US government? And what do you think about UFO sightings near Leh, Ladakh? So I have kind of looked into these UFO files or UAP files. I have found nothing that really intrigued me. I have found nothing that really interested me. There's no actual hard evidence of anything whatsoever. There are some documents, there are some transcripts of conversations and discussions and call logs and whatnot. But listen, that's just a document that proves nothing. I can create a fake document and put it up. Anybody can do that. The US government is known to, well, let's say, misrepresent things, right? So I have found nothing intriguing or really interesting. Nothing, there's no unambiguous evidence of anything whatsoever. Okay. What do I think about UFO sightings in Ladakh? Well, I've been to Ladakh a few times. I've never seen anything. Okay. And if people have seen things, well, maybe there's a, non-alien explanation of that. Maybe the Indian government is testing some very futuristic technology. Maybe the Chinese are testing futuristic technology. Futuristic aircraft of some kind. So you can very easily explain this off through conventional means without having to resort to the need for aliens. So I think if there are UFO sightings, then I'm sure there's a plausible, reasonable explanation that has nothing to do with aliens. Godliness says, why are we looking outwards? Maybe we are aliens landed on Earth in the form of DNA from somewhere else. Also, historic artifacts and drawings do show some visitors. Isn't that a proof of alien life? Okay. So why are we looking outwards? Maybe we are aliens. It's possible. So what you are referring to is called the theory of panspermia. Panspermia theory says that it's a hypothesis, it's a theory, whatever you want to call it. The theory is that The DNA came from outside our planet. Okay, so we know at what rate DNA doubles in size. Okay, so we have various kinds of DNA on our planet. We have viral DNA. Viruses, they also have DNA, very small DNA in size compared to human DNA. There's bacterial DNA. Some bacterial DNA is large, some is pretty small. There's the DNA of plants, there's the DNA of animals, there's the DNA of cats and dogs and polar bears and foxes and butterflies and fish, and there's our DNA. So we know different kinds of DNA, and we know at what rate DNA roughly grows in size. Okay, so if we extrapolate that backwards in time, then the simplest DNA molecule that you could have would have been formed about maybe when the universe was about a billion or so years old, a billion or 2 billion years old. And at that time, see, today we know what is the average temperature in the universe. It's 2.7 or so Kelvin. But in the past, the universe was smaller and the temperature was higher. And there was a time when the average temperature in outer space in the universe was about 25 degrees Celsius. The entire universe was a Goldilocks zone where you could have liquid water. So maybe life formed in outer space itself, wherever there was water. Maybe when the universe was about 2 billion or so years old. And maybe that life survived on space rocks after the universe froze. And whenever those space rocks go and hit a planet or whatever, sometimes that DNA will survive and it will seed the planet with DNA. And maybe that's how DNA ended up on our planet. And maybe our ancestral DNA came from outer space. So that is certainly within the realms of physics and logic. Yes. Okay. So maybe you are right. Maybe, but we don't know for sure. Maybe. Historic artifacts and drawings shows of visitors. Is that proof? It's not proof. It's just a strange drawing. It proves nothing. What is proof? Proof is actual hard evidence. Maybe a crashed UFO. Maybe the body of an alien. Maybe a handshake with an alien. That is hard evidence. Some strange drawing with bug-eyed creatures or whatever, it doesn't prove anything. It's just a strange drawing. It doesn't prove anything, okay? Godliness says, what if aliens manipulate AI? So scary. The existence of aliens who can come to Earth itself is so scary that AI is nothing compared to them. We are right now developing stronger and more powerful AI models. Every few months, there's a new one that comes out. But if you have aliens that are able to come all the way to Earth, then their technology will be way beyond anything our AI is. Okay? Because traveling across multiple light years in interstellar space, that is a feat of engineering way beyond anything we can even imagine today. So if you have aliens who can do that, their technology will be like thousands of years ahead of ours. So our AI will be nothing compared to what they will have. Okay. A. Rahul says, why is the Event Horizon Telescope not being used to capture pics of planets with potential life, like the planet that has phosphine gas, etc.? That's a good question. The planet that has phosphine gas is Venus, which is right next door. You can see it with your naked eyes. You can even see the phases of Venus, the crescent shape of Venus and all, with naked eyes. And if you have a binoculars, you will see the nice view of the planet and so on. So the planet that has phosphine gas, allegedly, is Venus. Now, the Event Horizon Telescope, it's not one telescope. It is not one telescope. It's a bunch of telescopes distributed across the planet. Okay? And it is designed to capture pictures of black holes. Okay, let's figure out what's the engineering behind this Event Horizon Telescope. Please explain the engineering behind the Event Horizon Telescope. What's the engineering? It's a global network of synchronized radio wave observatories that function as a single Earth-sized virtual telescope. Okay, very long baseline interferometry. Okay, glowing gas and shadows. Right? Extreme synchronization, hard-dressed, short wavelengths, and so on. Millimeter and submillimeter radio spectrum. So, because of the specific characteristics of this telescope, it can only be used. Okay, let's ask. Okay, can the event horizon be used to take pictures of planets? It can't. No, it can't. There you have it. It can't. Right. So you can go and look into it. What are the details? What are the reasons for it? But it cannot be used to take pictures of planets. It's got one purpose, and that purpose is to capture pictures, images of black holes, supermassive black holes, not regular size. I mean, what's regular? I don't know. Maybe stereo. So it's designed to capture images of supermassive black holes, the kind of gigantic, gargantuan black holes you have at the centers of most galaxies. That's what it is. What its only purpose is. Struggler says, what diet about Jacques Vallée's alien hypothesis? Who is Jacques Vallée? I am not aware of this gentleman. Let's find out. Jacques Vallée alien hypothesis. Who is Jacques Vallée? Dr. Jacques Vallée rejects the traditional extraterrestrial hypothesis, nuts and bolts idea that UFOs are spacecrafts piloted by biological aliens from other planets. He pioneered interdimensional UFO hypothesis. He argues that unidentified anomalous phenomena represent a sophisticated multidimensional intelligence or control system that has coexisted with humanity throughout history. What's the evidence? Zero. So, okay, so sure, I'm sure it's a theory that interdimensional. What is interdimensional? So maybe he has made some claims, but there is no evidence of that. Arman Khan says, good news. Let's see the good news. Sports Minister has submitted sporting passport proposal to PMO office to boost sports like football, tennis, basketball, rugby. Okay, let's find out what this is. Sporting passport proposal to Prime Minister's office to boost sports like football, tennis, basketball, rugby. Let's see what this is. The Ministry of Youth Affairs and Sports has submitted a sports passport proposal to the PMO and the Ministry of Home Affairs. If approved, it will allow eligible persons of Indian origin, PIOs, and overseas citizens of India to represent India internationally without requiring them to surrender their current citizenship. Okay, good. I think that's great news. That's great news. If you have people of Indian origin who want to represent India, then don't force them to give up their existing citizenship. I think it's a great proposal. I think you will get an approval in a few months, perhaps, hopefully, maybe a couple of years, within this decade at least. We'll see. I hope it's soon. Yeah, I think it's a no-brainer. And of course, you can have restrictions based on countries in case some countries are potentially problematic. But on principle, I think it's a great idea. So definitely good news, and thank you for sharing this with us, Arman. Varinder Singh says, suffering from derealization since heavy use of psychedelic cannabis. Universe feels different, may sound funny, any cure feels like soul sitting in head. Any cure. So you're suffering from derealization because you have heavily used cannabis, which is a psychedelic plant. Okay. How do people use cannabis? They either chew it, eat it, or smoke it, I suppose, right? Cannabis sativa. Okay, so because you've done this heavy use, the universe feels different. And this may sound funny. I suppose it's not really funny. Any cure feels like your soul is sitting in your head. Well, the cure is very simple. Stop using cannabis. You'll go back to normal. It's as simple as that. And or is it that you have stopped it and you're still feeling this way? In that case, it may. But I suppose you should see a medical professional, because I have no understanding of how these things work. I mean, I suppose if you stop using the psychedelic, see, cannabis is just a plant, right? If you stop using it, I suppose you should go back to normal in a few days. And if you've stopped using it and you're not going back to normal, I think you should see a medical professional. That's all I can tell you. I personally have no experience with this, so can't give you any specific advice. My only advice is go see a medical professional if you have stopped using it and you're still feeling this way. But if you have not stopped using it and you want to go back to normal, just stop using it. All right, sir. Varinder Singh, all the best. All the best. Get well. Pradeep Kumar Roy says, what are quasars? How are they formed? Quasars. Quasars are massively luminous light sources. Massively luminous. They outshine entire galaxies. But what are these objects like is the question. Well, a quasar is powered by a supermassive black hole sitting at the center of a galaxy. So we have a gigantic, monstrous black hole, supermassive black hole, sitting at the center of our galaxy. But it's completely quiet. It's making a few stars dance around, but that's it. There's nothing happening there. It's a very quiet neighborhood. But in some galaxies, you have the same kind of supermassive black hole, which turns into a monster. Why does it turn into a monster? This happens if there is a massive cloud of gas and dust and whatnot at the center of the galaxy. If you have that, then that obviously will get sucked into the black hole, but it doesn't go straight into a black hole. It goes round and round, this huge whirlpool kind of thing, and that gas and dust and everything else is accelerated to ridiculous speeds, like relativistic speeds, a significant fraction of the speed of light, like 50% of the speed of light, maybe 30-40% of the speed of light. So you have this incredible traffic jam of ridiculous quantities of particles that are all trying to enter the black hole. And that causes this huge luminosity, shocking luminosity. It outshines the entire galaxy. Okay? So these are some of the brightest objects in the entire known universe, quasars. These are simply black holes. They are swallowing and absorbing tremendous quantities of material. That's what a quasar is. How are they formed? They are formed because you have a supermassive black hole that's minding its own business at the center of the galaxy. But there's a big cloud of gas and dust, which is there. So because of the laws of physics, the black hole starts absorbing that. And that's how it's formed. Pradeep Kumar Roy says, are quark stars real or are they just a concept in theoretical physics? Well, nobody's ever observed a quark star. They are a concept in theoretical physics. Okay. If you study, particle physics, if you study quantum chromodynamics and the properties of quarks, and if you play around with the properties of quarks, you will see that quarks can form very strange objects called quark stars. Okay. So you certainly can have quark stars from the perspective of physics. They don't break the laws of physics. They certainly are possible as per physics, as are wormholes, as are white holes, as are magnetic monopoles. These all could exist as per the laws of physics, but we have never seen them. Cosmic strings could exist as a consequence of the laws of physics, but we have never seen them. But maybe we haven't seen them because we don't know where to look, because we don't have the right instruments to look for them. Right? So, as far as we know, we have never observed or detected an actual quark star, but they certainly could exist. Excuse me. Yes. Pradeep Kumar Roy says, Sam asks, what if the moon was tidally unlocked? It's very simple. If the moon was not tidally locked with our planet, then we would see the moon rotate actually. And we would see both the sides of the moon. Right now, we only see one side of the moon, right? Only one face of the moon. We never see the other side. It's because the moon is tidally locked. So the amount of time it takes to rotate once is the exact amount of time it takes to go around our planet once. That's why it's always displaying one side to us. If it was not tidally locked with us, we would see the moon's rotation and we would see both sides of the planet, as simple as of the moon, as simple as that. Pradeep Kumar Roy says, HKL asks about neutrinos. What are they? A neutrino is a subatomic particle. Okay, it's a ghostly particle. it interacts via the weak nuclear interaction. See, we have four interaction, four interactions or forces in physics. You have electromagnetism, you have gravitation, you have the strong nuclear force which binds nuclei together. You have the weak nuclear force which causes nuclear decay and so on. Okay, you have four forces. So neutrinos interact only via the weak interaction, the weak nuclear interaction. So neutrinos are these ghostly particles with extraordinarily small masses, okay, which are emitted by stars, by the sun. So every second of your life, trillions of solar neutrinos pass through your body, trillions of them, and none of them interacts with you. Maybe a few neutrinos will interact with your body in your entire lifetime, and the interaction will be just fleeting. You will not even sense it. Trillions of them are passing through your body every second. You feel nothing. So they are these subatomic particles. Okay, they were the existence of the neutrino was predicted by Enrico Fermi. It was Fermi who predicted that. You can double check that. Okay, and they are very small in mass. There is something called neutrino oscillations. There are different kinds of neutrinos: mu neutrino, tau neutrino, and so on. Okay, they come in different generations, and yeah, their interaction with it's very rare and very negligible. Okay, and shocking quantities of neutrinos are given out during supernova explosions and so on. So that's what a neutrino is. Sylvester Stallone Limited says CIPRI 2026 part: increasing focus on nuclear weapons amid heightened escalation risks, states that India targeted Pakistan's air surface nuclear bases in May 2025. Well, they seem to know things that they seem to know classified information. So they claim that India targeted Pakistan's nuclear bases in May 2025. Maybe that's why Trump got all panicky and interfered in the war. So if they claim, it doesn't mean it's, if they claim something, it doesn't mean it's actually happened, because they have no actual insights into what the government of India does, unless they have, but I don't think they do. Maybe it's deduction, maybe it's whatever, but okay. Pradeep Kumar Roy says, are gravastars possible opposite of black holes? What's a gravastar? I have not looked into that one now. What's a gravastar? It's not the opposite of a black hole. It's one of the exotic objects that could exist in the universe, but I've not really looked into their properties. It's not part of my thing. But let's see what a gravastar is. What's a gravastar? What is a gravastar? I said, what is a gravastar? What? What is a gravastar? Why the theoretical astrophysical object, blah, 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 blah. Alternative, ultra dense normal matter surrounding physicists. Okay, yeah, it's some kind of exotic hypothetical object, very exotic, very, I think, kind of a fringe proposal. No one's actually seriously looking for these things. So yeah, I've not really looked into these things. Gravastars, not important for me. Are they possible? I suppose they are possible according to the laws of physics, but Pradeep Kumar Roy says, what is Hawking radiation? How can it be calculated? Can it be used as a unifying factor between general relativity and quantum mechanics, proving quantum gravity? Okay, what is Hawking radiation? So Stephen Hawking, who is no longer with us, he was an English theoretical physicist. And I think sometime in the 20th century, he traveled to the USSR. He spoke to Lev Landau and other physicists. Novikov, Zeldovich, I don't know which one of these physicists it was who gave this idea to Hawking. And Hawking went back to the UK and he calculated things, and he discovered through his calculations that black holes actually have a temperature. Black holes are thermal objects. Black holes have a temperature. And what is the characteristic of any object that has a temperature? It radiates. So black holes emit radiation. And that radiation is called Hawking radiation. How is it calculated? The calculation is semi-classical. It involves, let's say, a combination of quantum mechanics and classical classical calculations. Okay, so I cannot derive it for you here because you won't get it. I mean, it's super complicated, super mathematical, but it's the derivation is a combination of classical and quantum elements. Okay, but you can think of it incorrectly. It's not a correct visual representation of what actually happens. But if you want an analogical understanding of Hawking radiation, it's like this. Okay, there is something, and this is not actually what happens, but it will help you understand perhaps. This is not exactly what happens. What happens is different, but here's one way of understanding it, which is not entirely correct. We know that there is something called quantum fluctuations. According to quantum field theory, we know that the vacuum out there in outer space, it's not really a vacuum. It's teeming with particle-antiparticle pairs that are being created and reabsorbed all the time. Okay? Every point of space in vacuum is teeming with these particle-antiparticle pairs that are created and spontaneously destroyed all the time. So that's quantum fluctuations in vacuum. A particle-antiparticle pair is created, and before the time limit that is inherent in Heisenberg's uncertainty principle, it is reabsorbed. The two particles annihilate each other before that the time violation happens from Heisenberg's uncertainty principle. So you don't violate the uncertainty principle. If you don't violate it, you can have these particle-antiparticle pairs that are created. So let's say you have a black hole with an event horizon. Okay, event horizon. And let's say a particle-antiparticle pair is created just outside the event horizon. So one particle goes this way and the antiparticle goes that way. And because it is created on the just outside the event horizon, maybe one particle goes inside the event horizon, never comes back, and the other one escapes. So this virtual particle-antiparticle pair became a real particle. But one particle was absorbed and the other was emitted. And this particle-antiparticle pair was created because of the gravity of the black hole, which is why the black hole foots the energy bill of the particle-antiparticle pair. But only half the energy was reabsorbed, half was lost. So the black hole actually lost mass and it emitted a particle. That's one way of incorrectly looking at this thing. So if you are at a certain distance from a black hole, which has a certain temperature, you will see radiation coming from the black hole constantly. And this radiation it's democratic. It's completely random, okay? It has a black body spectrum. So that's what Hawking radiation is. It depends on the temperature of the black hole. The temperature of a black hole depends on the mass. The larger the black hole, the colder it is. The smaller a black hole, the hotter it is. dm by dt is minus h k upon m squared. So the rate at which a black hole radiates, it's inversely proportional to the square of the mass of the black hole. Okay, the rate at which a black hole radiates Hawking radiation is inversely proportional to the square of the mass of a black hole. So it's dm by dt is equal to minus k upon m squared, roughly. And k is it's a bunch of factors. So that's Hawking radiation. Can it be used as a unifying factor? No, it can't. No. Sachin Kumar says, if most of the universe is dark matter, are we, along with Earth and all life, just a rare anomaly instead of the cosmic norm? Yes. Yes. So if you look at the mass energy composition of the universe, Everything you see, all the light sources out there, all the stars, all the planets, all the nebulae, all the quasars, all the pulsars, all the galaxies, everything you see, it's about 4% of the mass energy of the universe. Only 4%. Everything you see is just 4%. About 70 or 71% is dark energy. And about 25% is dark matter. Roughly. Okay? So about 70 or 71% of the universe's mass energy is dark energy. And about 25% is dark matter. And only 4% is ordinary matter that we see. So we are clearly a rare anomaly. We are clearly exotic matter in the universe. The regular matter is dark matter and dark energy. Okay? Right. Sachin Kumar says, does Indian mythology or ancient history feature any concepts or deities that parallel modern astrophysics' black holes? I am not aware of it. I don't know about anything that resembles black holes. Yeah. Sorry, I don't. Pradeep Kumar Roy says, are phantom particles the same as neutrinos? Also about the oh my god particle, do they seemingly violate certain laws of physics? I don't know what a phantom particle is. I know actual particles. See, journalists coin all kinds of names for particles. The God particle, the oh my God particle. I don't know what are the particles. I don't know what it means. The God particle was supposedly the name for the Higgs boson. I know what the oh my God particle is because it was that term was coined by a physicist. But I have no idea what these phantom particles are. That could mean anything. Yeah, so I suppose the neutrinos are ghostly phantom-like particles because they are so elusive, so hard to detect. So maybe phantom particles maybe they're referring to neutrinos when they talk about phantom particles. I'm not sure. Now, what is this oh my God particle? The oh my God particle was a cosmic ray particle whose energy was just utterly ridiculous amount of energy. What was it? How many GeV was it? Was it in the GeV range or MeV range? When I say MeV, GeV, I'm talking about mega electron volts and giga electron volts. Probably not the GeV range. Probably MeV range. Okay, let's. It was detected in North America. Probably in the 90s or 2000s. Probably in the 1990s or 2000s. Oh my God particle. And it had the momentum of a baseball or something. One single particle. Let's quickly Google it. Oh my God particle. Ultra high energy, UHECR, ultra high energy cosmic ray, 1991. It had the kinetic energy of a baseball thrown at nearly 60 miles per hour in a single subatomic particle. So, okay, it is exa-electron volts. Good gods. 320 plus or minus 90 exa-electron volts. Unfathomable energy. Okay, 20 million times more energetic than the particles accelerated in the LHC. So that was the oh my God particle, UHECR, ultra high energy cosmic ray. Now, how are these ultra high energy cosmic rays created? Well, one can think of various mechanisms. Hawking radiation could be a source. You can have more commonplace sources like quasars and whatever. Yeah, that sort of thing. So anyway, that's what the oh my God particle was. The oh my God particle did not violate the laws of physics, and neutrinos don't violate the laws of physics. Ankita Kachap, good evening, ma'am. Joined very late today. Starlink commercial launch in India on hold. Good for India. Absolutely good for India. I'm glad to hear this. I'm glad to hear that the government has decided to freeze the proposed launch of Starlink in India. I have argued for a very long time for the government to do this. I've argued that this is a very bad thing for India to allow an American company to beam internet into India. It should not be allowed. It is very dangerous potentially for national security. It can be used for all kinds of anti-national nefarious purposes. It can be used by terrorists. It can be used by separatists. It can be used by rioters. Right? It can circumvent government restrictions, temporary restrictions on internet. So I'm very glad that the government has decided to freeze this rollout, proposed rollout, especially in light of the US government's attitude towards India in the past few years, in the past few months. So overall, very good news. Sachin Kumar says, since stellar black holes are from dead stars, what created the supermassive giants anchoring our galaxies? Great question. It's an open question in physics. Okay. So one of the theories is that supermassive black holes started as primordial black hole seeds. So you have a supermassive black hole at the center of a galaxy. It's, let's say, several million solar masses, but maybe it started as a tiny primordial black hole. What's a primordial black hole? Primordial black holes are very ancient, theoretical, very tiny, microscopic, ancient black holes that were possibly produced in very, very large quantities in the very early period of our universe. Okay, so there were different epochs in the very early universe where primordial black hole overproduction could have happened. Very large quantities of primordial black holes could have been produced. And the question is, what happened to those guys? What happened to them? Did they all disappear, or are they still around, or do they serve some other role in the universe today? So one theory is that some of these primordial black holes, how did the primordial black holes form in the universe? Because of quantum fluctuations in a very dense universe. So in a very extraordinarily dense universe, a quantum fluctuation can create a small region of overdensity, where the density is greater than the Schwarzschild density, let's say. Okay, and that creates a black hole. And maybe these primordial black holes, some of them at least, served as seeds of what eventually became supermassive black holes. That's one theory. We don't know for sure. We don't have the clear answers even today about how supermassive black holes ended up forming, and why do most galaxies have supermassive black holes at the center. So it's still an open question, but one potential answer is that maybe primordial black holes were the seeds that eventually grew larger and became supermassive, what we have today. Sachin Kumar says, I've heard the theory that there's only one electron in the universe moving backwards and forwards in time. How viable is this? Well, physically, it kind of is viable, actually. Mathematically, going forward and backward in time. It's an interesting theory, the one electron universe. It's not something that actually violates the laws of physics, actually, Yeah. So it's kind of a potential answer to the question. I mean, maybe there's just one electron in the universe going forwards and backwards in time. Who proposed it? A famous physicist. I forget who it is. Was it Dirac? Was it Dirac? Who was? I don't know. Let's see. Which physicist proposed the one electron universe theory? Okay, Wheeler. J.A. Wheeler. Okay. Electrons and positrons moving forward and backward in space-time. Right. So it was John Archibald Wheeler, the co-author of one of the greatest books on gravitation of all time. Okay. It's this massive. And so it was him who proposed this. And kind of makes sense. Okay. Sachin Kumar says, beyond Pluto, what is the scientific basis for the Planet 9 theory? Why haven't we been able to see it yet? Okay, good question. So you see, like we discussed some time ago, our solar system formed from an ancient, gigantic cloud of gas and dust. That cloud of gas and dust came into existence from the death of a previous star. So our sun, the sun, is maybe a second or third generation star. Okay, so it was initially just a gas blob, gigantic cloud of gas and dust, but eventually it started coalescing together. The center, more mass came together, and it eventually became a protostellar disk. What does a protostellar disk look like? Okay, protostellar disk. What's it look like? It's flat. Okay, you can see it's flat. As you can see, this is a real image. It's flat. It's like a discus. You know, discus throw. It's like a discus. It's flat. So the entire solar system, because of the protostellar disk being flat, it is in one single plane essentially. You have the sun, and you have all the planets going in roughly elliptical orbits around the sun in the same plane. Okay, so it's not like the sun is here and the Earth is going like this, and the Jupiter is like that, and Saturn in some other direction. No, they're all more or less in the same plane, the ecliptic. Okay, so all the major objects in the solar system, planets, planetoids, planetesimals, dwarf planets, they should all be roughly in the same plane. Now, beyond Pluto, there are some weird objects out there that are not in the same plane as the other objects. Some are inclined. Some of them have orbits that are inclined at strange angles to the ecliptic, which indicates something happened out there. There's something out there that is messing around with these planets. Maybe there is some object out there whose gravity is tugging at these planets or these objects and messing up their orbits. Okay, so because we have these strange orbits of distant objects in the solar system beyond Pluto, that is what tells us there is something out there. Maybe there is something out there right now, or something went through this region which messed up the orbits. And if you do the calculations and all, it looks like there is something that is multiple Earth masses and far away. So maybe there is a planet out there, which perhaps is a super Earth kind of planet, but it is so far away that almost none of the light from it comes to Earth. So you see, Pluto is very far away, and some percentage of this. What is the albedo of Pluto? Let's see. What is the albedo? What is the albedo of Pluto? Pluto is reddish, right? 0.72, which means that it reflects about 72% of all incoming sunlight. What is the albedo of Sedna? 0.32. Okay, it's darker. It's darker. So it reflects about 32 to 41% of the sun of sunlight. What's the albedo of the moon? Less, 7%. Yeah, 0.12, 12% of the sunlight. So the moon is pretty dark. So maybe this object has a low albedo, and maybe it's really, really, really far away. In that case, it will be almost undetectable. Yeah, it'll be almost impossible to discover it. So maybe it's a big object, but it's really far away, far, far away from the sun, and that's why it's almost undetectable. And another theory is that maybe it's a primordial black hole, in which case you will never find it. So these are some of the reasons why we haven't been able to detect it so far. We have only been looking for it for the past 10, 15 years. And the space is vast, right? So it's very hard to find this. Pradeep Kumar Roy says, I asked AI to state the defects in humans. It gave me a long list, and after a few minutes stated that the ultimate solution is human extinction. Existence of highly intelligent life in space impossible. Are you asking me two separate questions? Because the first one is a statement. You asked AI to state the defects in humans. It gave you a long list of defects that humans have, and then stated that the ultimate solution is human extinction. Which AI was this, is the question. You could have specified which AI it was. That would have been rather instructive. Is it, which model is it, is the question. Yeah. Okay, so, all right. That's a little creepy. That's a little concerning. Existence of highly intelligent life in space impossible? It's not impossible. It is possible. It is possible. There is nothing in the laws of physics that says that existence of highly intelligent life out there is impossible. No, it's very much possible. Sachin Kumar says, could dark matter simply be gravitational bleed in from a parallel universe or higher dimension? Um, Look, when we talk about other universes, we're no longer discussing physics. I'll tell you why. It's physics if you can prove it and also falsify it. A theory is within the realm of physics if it is falsifiable. Let's say I make a claim that there is a Hawkins pressure cooker in orbit around the sun between the orbits of Jupiter and Saturn. I mean, there's nothing in the laws of physics that says it can't happen, but there is no way to prove it or disprove it because it's such a small object and it's so far away, we will never be able to detect it. So if I make such a claim, it's neither provable nor falsifiable. If a claim is not falsifiable, it's not physics. Okay? So now when we talk about other universes, there is no way for us to detect another universe. There's no way. We don't even know what's the extent of our own universe. We can only see a small subset of our universe. So talking about something beyond our universe is, well, if it exists, it's not provable or falsifiable. So we don't, yeah. So could dark matter be something like this? It could be, but well, that's not the kind of theory we actually entertain in physics. We look for solutions from within our universe, not from outside our universe. Okay. And I don't know what a higher dimension is. I mean, we know that we have 4 dimensions: length, breadth, time, and space. That's the 4 dimensions of general relativity. You could have a 5th dimension as per the Kaluza-Klein theory. Kaluza-Klein theory, 5-dimensional theory. You could have 10 dimensions or 11 dimensions as per string theory, superstring theory. You could have 26 dimensions from bosonic string theory, but what's a higher dimension? Okay. Sachin Kumar says, off topic, with the US government stepping in to kill Fable 5 or jailbreak fears, are we seeing the beginning or the end for open AI development? I think we are hitting the limits of what the US government will allow non-Americans to use, and even Americans to use. I have been saying this for such a long time, that there are AI models behind closed doors that go way beyond anything that is available in public. And now Anthropic developed a model that the American government says it's too powerful, and the rest of the world should not have it. So it was available outside of the US until yesterday. But if you woke up today in India in the morning and tried to access it, it was gone. Right. So it's not the beginning of the end for open AI development. There'll be other countries that will keep developing AI and keep making those AIs available, open source. You could go to Hugging Face or whatever and download the weights. Weights. What are weights? What are parameters? Right. Weights essentially are it's like coordinates. Okay. So in a Cartesian world where you have x axis and y axis, you have coordinates, right? X and y. In a 3-dimensional Cartesian world, you have x, y, and z coordinates. So you have points in space, x, y, z, with x, y, and z coordinates. In a 4-dimensional universe, you have x, y, z, and t coordinates. But in AI, you have tens of thousands of dimensions. Okay? And each word, each token has its own coordinates and the way things cluster. So it's geometric clustering in tens of thousands of dimensions. That is weights. Anyway, that's not what you asked, so I'll not elaborate further, but that's how it is. So you will still have development of open source AI systems until even those become too powerful. Eventually governments are going to restrict these things, obviously. Empty Box says, if we are sand castles returning to Earth, why this separate existence? Is full awareness of that, is that enlightenment? Best beginner space study recommendations. I don't know if we are sand castles returning to Earth. I don't know about that. Why the separate existence? I am sure there is some reason for it. Maybe there's a reason in the laws of physics. I mean, so we are now beginning to merge philosophy with science here. But according to various traditions, there's only one consciousness and so on, which I will not comment about because we're discussing science here. But I don't know if we are sand castles returning to Earth. I don't know about that. Maybe we just pieces of flesh. That's also one way of looking at things. Maybe right or wrong. We don't know. I don't know. Why this separate existence? I don't have the answer to that. I don't have an answer. It is what it is. Is full awareness of that enlightenment? Maybe. I am not the person who can answer that question. Best beginner space study recommendations. Beginner space study. I suppose you could read Carl Sagan's Cosmos. It's a beginner book. Or you could read Stephen Hawking's A Brief History of Time. I remember reading that as a kid. Like I was like 11, 12 years old. So yeah, Carl Sagan's Cosmos, let me recommend that. Carl Sagan Cosmos book. So this book here by Carl Sagan, that's a good book. I suppose it's a pretty beginner book. The other one is A Brief History of Time. This one here, that's a book I looked into as a kid. That's also, if I recall correctly, a beginner book. So yeah, I suppose you could start with that. Is it all space? I think Cosmos is about space, and Stephen Hawking's book is more about theoretical physics. Generally, it's about a popular introduction to theoretical physics and astrophysics and cosmology, I suppose. So Chin Kumar says science says human intelligence is declining. No, when did it say? What? Science says human intelligence is declining. I do not agree with that at all. Where does science say that? I am not aware of this. Human science says. Which science? Is there some scientific study that I'm not aware of? Human intelligence is declining. Are we evolving backwards, you mean? Back to monkeys? Reverse Flynn effect. What? Let me check this out. What is a reverse Flynn effect? Reverse Flynn effect. What's that? Oh, fascinating. Reverse Flynn effect describes a recent well-documented trend in several developed countries where average generational IQ and cognitive test scores have begun to decline, reversing a century of steady increases. Fascinating. You are saying, okay, you are actually referring to something that is out there. So while the traditional Flynn effect saw average IQ scores increase by about 3 points per decade from the 1930s to 1990s due to better nutrition, education, and living standards, the trend has reversed in recent decades. Okay. So what could be the reason for it? Okay. So we're talking about IQ over here. We're talking about IQ here. We're not talking about actual intelligence. IQ is intelligence quotient, which is not really a good way of actually measuring someone's intelligence. It's standardized testing and all. It doesn't really it doesn't really measure your true intelligence. IQ, for example, if you ask Nassim Nicholas Taleb, he will say that IQ is a pseudo-scientific swindle. And the way IQ data is collected and IQ scores are calculated, a lot of it is completely fraudulent. Anyhow, let's say IQ scores are declining. So it's not human intelligence that is declining, it's IQ scores that are declining. What are the causes for that? Declining standards in the various education systems worldwide. The US education system was way better in the 1950s than what it is today. Today, even the US education system has declined significantly. Right? So that's one reason. Second is this. Scroll. Kids are scrolling their smartphones all day. It's causing what's it called? Brain rot. So these are two massive reasons for the decline in IQ in the past couple of decades, whenever. Parental drug abuse, I don't think that's such a widespread thing, unless you're in the US. In the US, everyone takes drugs, but other countries, I don't think so. So I think it's declining standards in education and addiction to social media and these reels and all that's causing these issues. NVM says, if the asteroid wiped out dinosaurs had missed Earth, how might evolution have progressed? Even if humans never evolved, would some other form of intelligent life likely have emerged? Yeah. Maybe you would have had intelligent dinosaurs by now. Maybe they would have reached Mars or something by now. Who knows? Right. So first of all, the asteroid from 66 million years ago did not wipe out the dinosaurs fully. It wiped out the non-avian dinosaurs. The avian dinosaurs managed to survive. Now, what do these avian dinosaurs look like? They're around. I saw them a couple of hours ago. Avian dinosaurs, I saw them. What do they look like? Avian dinosaurs. What do they look like? Well, that's what they look like. Is birds, right? See, birds. So they are still around. The birds are still around. They are the descendants of the avian dinosaurs. Birds are dinosaurs. Your chicken is a dinosaur. Your turkey is a dinosaur. Your pigeon, your crow, your nightingale, your hummingbird, they're dinosaurs. So the asteroid did not wipe out all dinosaurs. Okay. But let's say it had missed Earth, then probably we would not be here. And maybe you would have perhaps suit and tie wearing dinosaur humanoids out there. Who knows how it would have evolved? It could evolve in 78 million different ways, right? Depending on so many different factors. So there's no way of telling how life and intelligence could have evolved or would have evolved on our planet. Could be any of 78 million or trillion different combinations of directions it could have gone into. But yeah, it's possible that some form of intelligent life may have evolved on our planet. It's possible. Sachin Kumar says, why do you say astrophysics has been hijacked by the string theory mafia, and what can be done about it? I'll tell you why. See, string theory emerged as an attempt to reconcile two very disparate and two very successful theories. The two most successful theories of physics that we have today are, on the one hand, quantum mechanics, on the other hand, general relativity. Quantum mechanics is the theory of the ultra microscopic world, subatomic world. Okay? The distance scales are tiny in quantum mechanics. Quantum effects become apparent at very tiny distances and very tiny scales, length scales. General relativity is the most successful theory of the large scales, cosmological scales. But the two have to meet somewhere, and we're not able to reconcile them. If you try to construct mathematically a black hole, okay, from the inside out, quantum mechanically, it doesn't work. The black hole is weird. It has weird properties and characteristics that don't match general relativity. Okay? If you try to make quantum mechanics work in curved space-time, it doesn't work. And there are all these issues. But the two theories have to meet somewhere, because they are both successful in different domains, in different length scales. So that's why string theory emerged as an attempt to reconcile string theory and quantum mechanics. Quantum mechanics and general relativity. The objective is to have a quantum theory of gravity, quantum gravity. So string theory was an attempt to make that happen. So what if the most fundamental particles are not actually subatomic particles, but single dimensional vibrating strings? That's the fundamental concept. Okay. So that emerged in the 1950s and 60s, string theory. And that took over physics departments in the US. If you want to do a PhD in theoretical physics in the US today, in 9 departments out of 10, you have to do it in string theory. Otherwise, you will not get funding, you will not get approval. So it's like a mafia that's taken over. You join us or you're out. So if you want to do theoretical physics, you have to do string theory in the US. So all the funding goes to string theory. All the PhDs come from string theory. And all the other potential approaches to solving big problems are marginalized. If you take a different approach and you try to publish a paper, the paper isn't accepted, it's rejected. That's the kind of issue people are facing. Okay? There are many other approaches to try and quantize gravity or reconcile the two theories, but only string theory, if you want to have a successful career in theoretical physics in the West, especially in the US, North America, it's string theory or nothing. So that's why I say it's been hijacked by the string theory mafia. What can be done about it? Well, don't do physics in the US. Do it somewhere else. Maybe India has a great opportunity. But India doesn't care about that. Anyway, so. NPS says, I feel Dr. Günther Kleczka, 3 independent times dimension theory is quite fascinating and might be proven true in the future. What's your POV? I am not aware of Dr. Günther Kleczka. Let me find out who this is. Dr. Günther Kleczka. Okay, Geophysical Institute. His theory of 3-dimensional time. 3-dimensional time. Fascinating. So let me see. Do we have an archive? Let's see. Archive. Does he have paper? Okay, Google Scholar. Look, if somebody isn't on archive, it doesn't mean he's not a good physicist, okay? But let me see. Okay, let's see Google Scholar. What's he have to say? Research Associate Professor at the University of Alaska. Let's go by year. What's the latest? Platinum group elements, shock quartz, stratigraphic separation, cometary dust, microspherules, brain, 600 kilometers, Holiday et al., Younger Dryas. So he's doing research in multiple domains. Consciousness is a multidimensional temporal integration. Some of this is speculative. Where is the 3-dimensional time thing? There's a lot of geophysics and whatnot. So I don't see the 3-dimensional time thing over here. So I'm not aware of this, unfortunately. And I'm not going to waste everyone's time looking for that. So, yeah, I don't know. Rohan Bidi says, education system is useless. Well, you're telling me. How can we inculcate or encourage scientific temper in those around us? Without critical thinking, we can't maximize our potential. I don't know. I mean, you can try and talk to people around you and motivate them and make them see the truth, make them see the light. You have to do it without being preachy. You have to do it without sounding like you're giving lectures. How do you do that? It's pretty tough. You have to do it through various means. First of all, kids already have to spend so many hours mugging up their books. On top of them, if you are someone who wants to give them lectures about all this stuff, they will just ignore this guy. It's very hard. The education system should do this, but the government has absolutely no interest in that. So I don't know how to do it. One can do our own thing. Maybe, I mean, I keep saying raise your standards. I should also explain what do I specifically mean by raise your standards. So, these concepts are intuitively, you can sense they're important, but how do you make it happen? That's the hard part. It's not easy to develop someone's scientific temperament. It's not easy to teach someone how to think critically. Thinking critically means you're asking somebody to go through pain, because critical thinking is painful, at least initially, until it becomes second nature. But you're asking somebody to actually think. See, you're already mugging up stuff and all, which is not really thinking, but you're mugging up stuff. On top of that, now you have to exercise your brain power and think in different directions. It's tough. So I think it's pretty difficult. How do you do it? That's a good question. I don't really have the answer right now. I can tell you how to do it, but maybe I should be more specific as to how to think critically, step by step. A course in critical thinking, a primer in critical thinking, a book on critical thinking. I could do that. Will anyone buy it? Is the question. I don't know. Yeah. Karthik says, thoughts Indian government response on 3 sailors killed. Very meek, very subdued, very diplomatic, very non-confrontational, very low aggression response to 3 sailors killed. Because the US is the big boss. I mean, imagine if somebody kills 3 American sailors, how the American government's response will be. But our response has been that of a weak, meek, that sort of country. Disappointing. But you know what? What can India do? Sir, please listen to us. Plus, sir, please take note of our concerns. That's all we can do. We don't have any real hard power against the US. Unless we want to go to war with them, which we don't want to. So there we are. So Chin Kumar says, why is the sphere the most common shape in the universe? Right? So most planets are spheres. Stars are always spheres. All planets are spherical, actually. Right? It's the shape that takes the lowest amount of energy to assemble. See, if you want to assemble a triangular pyramidal shape in space, and if your size is massive, then the self-gravity of the system itself will make the whole thing crumble unless it is super, super strong. Okay? So why do planets assume a spherical shape? Because that's the most naturally stable shape. Okay? If you have an object which has the mass of the Earth, let's see, what's the mass of the Earth? What is the Earth's mass? 10 raised to 24 kilograms. And let's say you create a triangular or pyramidal shape out of it, it simply won't be sustainable. Gravity itself will tear into 2 pieces and make it spherical. So it's the most stable shape in the universe. And that's why everything is mostly spherical. Water droplets are spherical. Everything is spherical because it's the most stablest shape. Pradeep Kumar Roy says, thank you for doing a space episode after so long. You're very welcome. This is actually what I enjoy the most, but the viewership typically is very low when I do these episodes, but it's okay. I'm very glad I'm doing it. You're very welcome. NVM says, time dilation allows travel to the future. Time dilation allows travel to the future relative to other observers. Not quite. Does physics allow travel into the past, or is it impossible as per the laws of physics? First of all, time dilation does not allow you to travel to the future relative to other observers. It's not time travel. It's simply that your clock it moves at a different speed as compared to a stationary observer. It's a good old twin paradox, right? You've got twins. Both are 20-year-old guys, let's say. Okay, one stays on Earth, the other one goes on a journey in space at relativistic speeds. Okay. So you have time dilation. So let's say it's a certain fraction of the speed of light. And for the guy who's in the rocket, who goes on the journey, maybe 10 years pass. And then he returns to Earth and he expects that I am 30 now. My twin brother will be 30. But he comes back and he finds that this guy is 80 now. So that's time dilation. It's not time travel. It's time dilation. You're not traveling to the future. Time is moving slower for you. That's what it means. Okay? So understand this, please. Time dilation does not mean that there is time travel. You're not traveling to the future or whatever. Okay? It only means that time is moving. Your clock is ticking at a different speed compared to an observer who is stationary. That's all it means. Does physics allow travel into the past, or is it impossible as per the laws of physics? Well, as far as we know it, well, if you kind of you could travel into a different timeline. Past, look, if you use wormholes and stuff, you could potentially travel to the past, to the future. You will end up in a different timeline somewhere, in a different region of space time. But most likely, time travel to the past will be forbidden because it will cause causal paradoxes and inconsistencies which could break the fabric of reality itself. So yeah, I would say time travel is forbidden, the laws of physics. Sachin Kumar says, last one for today. What rips in big rip in what's left? Thank you for all the knowledge. You guys, please like and upvote. Thank you very much. Please like, subscribe, upvote. I know so that. What's this big rip? What's left? So the big rip is when, okay. So we know the universe is expanding and the expansion is accelerating. Okay. So what is expanding? Space-time is expanding. Space-time is itself getting stretched apart, right? Space-time. It's like you're blowing a balloon and the balloon is getting bigger and bigger and the surface is getting bigger and bigger, right? That's kind of what's happening. Space-time is expanding. So eventually, dark energy is going to dominate the universe. And eventually, there's going to be so much expansion of space-time that all the stars, all the galaxies will be stretched. I mean, they will move away from us, and the only thing around us will be the Milky Way. That will be the only observable set of stars. Eventually, even that will disappear, and only the solar system will be left that we'll be able to observe if we go that far into the future. Because the sun is not going to go supernova; it's going to become a white dwarf. It'll become a red giant and then a white dwarf, and that white dwarf is going to be around for probably trillions of years. So eventually, the universe expands so much, even the Milky Way is torn apart. Only the solar system is left. Eventually, even the solar system will be torn apart because of the expansion of the universe. Only the Earth will be left. Eventually, there'll be so much accelerated expansion of the universe because of dark energy that the Earth will be torn to shreds. Eventually, atoms will be dissociated. Eventually, there'll be nothing left, and that's the big rip. Okay, if that's what's going to happen, we don't know what the eventual fate of the universe is going to be like. Maybe there's never-ending expansion and a big rip. Maybe the expansion eventually stops and it contracts. That's a cyclical universe. So there are multiple scenarios depending on how flat or not the universe is and so on. Okay. Dheeraj Kamath says, knowing the US, they won't hesitate to bully, harass, and hold to ransom the family members of Indian government officials, family members, to advance geopolitical motives, will they? They're compromised. Well, everything is fair in love and war and geopolitics. Everything is fair eventually. Okay? You can talk about all kinds of nice things about free trade, about rules-based world order, and then you can go and bully countries, attack countries, kill world leaders, withhold Fable 5, Anthropic's Fable 5. You can do whatever you want as long as the most powerful country. So if push comes to shove, they may even do what you are referring to here. Yeah, that's always a possibility. It's the good old hostage system. The Roman Empire had the system of holding hostages. You would treat the hostages very well, but they'll still be hostages. It's the same old system. And I don't know why the government of India is not waking up to this the way the Chinese have woken up to it. It is what it is. Gaurav Pandey says, what do you think about the debate around data centers being built in India? Is the water usage issue as dangerous as being claimed by those opposing? India is one of the nations with the most critical water scarcity. What do I mean by that? How much water is available per capita? India has one of the lowest amounts of water available per capita, fresh water. Okay, that's a big issue for India. Now, if we build data centers in India, they will first of all need large quantities of energy, electricity. Secondly, for cooling, because these data centers, they produce a tremendous amount of heat. They have to be cooled. For that, you need water and not seawater. You need fresh water. Okay. And that too, where will it come from? Rivers and whatever. So that's fresh water that you would otherwise would want to use for people. But that fresh water, when it is used in data centers, it heats up, it evaporates. A lot of it evaporates. A lot of it is wasted. And do data centers generate jobs? Very little job creation. So overall, I think as long as it's our data we are hosting, of course we should host our data within the country. But providing such services to other countries for a little bit of cash and no job, very little job creation, and so much consumption of electricity which comes from which we have to generate, and wastage of water, I don't think it's a great thing to do, right? Because we are earning money, let's say, from foreign companies or foreign nations for this, but we are powering that with our electricity that we are generating. And we have a shortage of everything in India: electricity, water, employment. So I think it's not a great idea overall. Okay, 025 Kamal says your views on block universe theory. What is a block universe theory? The block universe theory, what exactly was it? It's that time, past, present, future are all together. Is that what it is? I don't remember. Let me see. What is the block universe theory? What is the block universe theory? Yeah, past, present, and future all exist simultaneously in a four-dimensional space-time continuum. So all moments exist together, and now is relative and all that. Yeah, it's kind of like general relativity, but I have not really myself looked into it, so I don't know, right? Yeah, I personally have not ever used this theory in any sense, in anything, in solving a problem or yeah. So I don't know much about it. I never used it. Never used it. General relativity, I understand. Quantum mechanics, field theory, I understand. Block universe theory, I am not really sure about that. I don't think it's a very mainstream theory. If it is, I'm not aware of it. Probably not a big mainstream theory. Mainstream, you have general relativity and cosmology, and quantum field theory. Cosmology, astrophysics is also here and there. So yeah, block universe theory, not my specialty. Sorry about that. The Hell Dragon says, are the theological ideas of creation, expansion, Brahma, dissolution, contraction, Shiva, preservation, evolution, Vishnu in line with modern physics? I don't know. I never ever mix religion and physics. Religion and science, I never mix. Never. So I don't know if it's in line with that or not. Sunil Kumar says, is it possible to have non-local influence over events? Non-local influence over events. I don't know. What exactly do you mean by non-locality? Are you using it in terms of quantum mechanics? If you're using it in terms of quantum mechanics, do you know what quantum non-locality is? What is influence over events? So I don't know about this. Can you have non-local influence over events? Yeah, I don't know. Sorry. All right, I think that brings me to the end of today's live stream. That was the last super chat for today. So thank you, everybody. Thank you very much for all the questions. A great bunch of questions I got from the comments, and a lot of interesting questions from the super chat as well. So it was fun doing this. After a long time, I've done a live stream on aliens and space and science. It was fun. Thank you so much. And I look forward to seeing you tomorrow in tomorrow's live stream, in which we will discuss anything else that you want. Until then, take care. As always, keep learning, keep asking questions, and keep raising your standards. See you soon tomorrow. Bye-bye.